Hello everybody and welcome back to another mini projects tutorial. In this video, we're going to be showing how to build this to-do app that you can see here on my Android emulator. Now this is built in Kotlin using Jetpack, Compose, Material 3, coroutines, Dagger-Hilt for dependency injection, a local room database for the cache, and we're using a Retrofit interface for making HTTP calls to an online real-time database that we're hosting on Firebase. We're going to be using our MVVM design pattern along with our clean architecture best practices. And as a bonus, I'll even show you how to generate this custom data that we can use for our app for testing and for demo using an AI. But before we launch into all of that, make sure to like this video, subscribe to our channel for additional content, and then definitely leave a comment down below telling us what you think about this tutorial and about this video. And also, if you have any questions, you can put them down in the comments below as well. This is still what we would consider to be a simple app, but if you're just starting Android development or Kotlin, maybe consider starting with our Android Starter course playlist or our Jetpack Libraries playlist, because I explain things in a lot better detail in those videos, and those are more aimed at beginners, whereas this one is going to be a little more advanced. So if at this point you're already thinking, this is just way too complicated, MVVM, clean architecture, retrofit, dependency injection, what is all of this stuff? Well, you don't need to worry about it. You can just email igiveUp@skyfish.dev, and we'd be more than happy to take your money and then provide you with a mobile solution that'll work for you. So if you look over in our app, you can see that we have this big long list of to-do items in here. I can click on any of these and mark it as completed. I can click this arrow button here, which you'll notice changes the color on the background, and that marks it as archived. And if I click on my menu up top, I have the option to either display the archived or not display the archived items. So I'll just leave that on for now. I can sort by the title, by the time it was created, by if it's completed or not, and I can go both ways, either ascending or descending. So if I come back here, if I click on one of these, and let's say I click on the buy food item, you'll see it takes me to another page. I can mark it archived in here as well. I can mark it completed or not in here as well. And then I can add an update here. And hit save on that. And you can see that update now populates here. So all of these to-do items are stored in a local room database that we're using for a cache, as well as in a real-time database that we're hosting on Firebase. And another thing about this app that you'll notice is if I rotate my screen here, you can see that the background rotated with it. And if I click on one of these items, maybe call mom, for example, which reminds me, I should call my mom. If you look at this item, you can see here we have our floating action button, but when we are rotated like this, our top bar and then our bottom bar have disappeared. So if I rotate that back, you can see our bars show up again. Or if I click in here, you can see our bar moves up with the keyboard so that the keyboard doesn't hide any of our buttons there. Or if I'm rotated, and I click in here, you can see the bar disappeared, but now the floating action button moves up with the keyboard. And we have a background here that looks good, both when I'm horizontal in landscape or when I'm in portrait mode. So that is really all that we're going to be building here. If that's something that you're interested in, then definitely stick through till the end of this video. Again, it's going to be a long video. There's a lot of content. There's a lot of code that we have to write to get there. But I think at this point, at least, out of all the videos on this channel, you'll learn the most from this app here. So let's go ahead and get started actually writing some of the code that we need to create this project. Okay, so first we need to go ahead and create a new project. So I'm going to close out of the project that I have open right now. And then in here, we're going to click New Project. And if you have an updated version of Android Studio, you should see this empty project with the Compose logo inside. If you have an older version, you may see an empty Compose project down beneath in one of the other templates. But if you have an older version, just update. So I'm going to click an empty activity. We're going to go next. And I'm going to go ahead and name this just to do. And I'll use my website on that. So dev.skyfish.todo. You can just leave that as com.example or whatever package structure you want there. And we're going to save it just in Android Studio projects. That is fine. I'm going to leave the API at 30. Obviously, if you're planning on testing this app on older devices, you need to adjust that. So click finish on that. And here we go. We have our empty compose activity. The first thing I'm going to do is just delete all of this auto-generated, the greeting and the preview that you have in the main activity. We're not going to want any of that. And then delete that greeting out of there as well. And just for your reference here, if I go to help and then go to about, you can see what version of Android Studio that I'm running. Obviously, if you're running a newer version, that's totally fine. All of this still should work with no issues. You may have a few layout updates or button updates or option updates along the way. So if it doesn't match, that's why. Not a big deal. I'm going to go ahead and upload this initial code to GitHub just in case if you want to follow exactly what I'm doing. I'm going to update my initial project, and then we'll have several checkpoints along the way where I upload my code at that point for this video. Let's go ahead and update our dependencies. So inside of the Gradle scripts, let's start off with the project level Gradle script file. And in here, above the plugins, I'm going to add a build script section. So build script. And then inside of the build script, I'm going to add a dependencies block. And then inside of that dependency block, I'm just going to copy. Feel free to pause the video and type that out, or you can pull it from our GitHub page. And then down here in the plugins, we have these default plugins that we started with, but we have a few more that we need. I'm going to add an Android library plugin here. And then I'm also going to add a KSP plugin, which is it's an annotation processing tool that's replacing CAPT, which is a Kotlin annotation processing tool. But if you don't know what that is, don't worry about that. Not a big deal. Once we have that all set up, you go ahead and go over to build.gradle KTS. Now, in this file, again, in the plugins up top, we have a few things that we need to add. So first of all, we need to add Dagger-Hilt because we're going to be using that for dependency injection. And then we need to add KSP and CAPT because we're using both of those as well, because not all libraries support KSP yet. So that's what we need to add in the plugins section. And then down here, all of this should be good, except here, at least for me, this is Java version 1.8. Now, if you go to File, Settings, and then Build, Execution, Deployment, Build Tools, Gradle, this will tell you what version of Java you're running. So here you can see I have JetBrains 17. So I'm running Java 17. And here this is set to Java 8. So I don't want that. I want to replace that with 17 on both of these. And then down here for 1.8, again, I want to replace that with 17. Down here, I'm going to just update the core to the newest version and then my compose as well to the newest version. And you'll notice here, none of these compose dependencies have any version after them. And that's because this is a fairly new thing that they've put in. But the bill of materials here, the BOM, bill of materials, this is a versioning package. So this is actually going to contain all the version information that we need for all of the additional composed dependencies. So all I need to do is put the version on the bill of materials, and that's going to ensure that every version that it assigns to all of these is already the correct version that's compatible with each other. Now I have a whole bunch of different third-party dependencies that I need to add, and I'm just going to put them in below this. First, we have a few extra actually composed dependencies we need to add. We've got our life cycle navigation composed. This is the material 3 icons, and then Dagger-Hilt navigation. We need to add our coroutines because we're going to be using coroutines. We need to add our Dagger-Hilt dependencies. And then this is red because we haven't synced the project yet. We need to add our room dependencies. And then same thing with KSP, that should clear up once we hit sync. We need to add our room dependencies, and then Retrofit and JSON for deserializing data. Okay, so I'm going to leave this here for a second, and you're welcome to type up all of that if you want to. Or a better approach, you can go on over to our GitHub that we have down in our repository that we have down in the description below, and you can just copy all of that and paste it into your project. Now, make sure to hit sync now. Now that we've got all of that set up, let's go ahead and build out our package structure for this application. Now, I'm going to be using clean architecture best practices. So in here, we're going to do a new package. And this is going to be in clean architecture. You're going to have one package for every feature. So this is going to be feature to do. And then this is actually the only feature that I'm going to put in this application. But if I were to add another feature here, I would go ahead and just add another package right here for that feature as well. But here, I'm not going to add any more features, but I am going to have a core feature here. And that's not necessarily a feature, but that's going to contain elements that are going to be common to all of the features. And there's a few things in this application that they're going to be pieces that we would use if we continued on and built out other features for this. So I'm going to put all of that in the core. And then after that, inside of your feature to do, you're going to have 3 packages, one for data, and then one for your domain, and then finally one for your presentation. And the presentation layer is, of course, going to hold all of the composables and the view models and everything that goes with the screens and what we're displaying. The domain is going to hold all of our business logic and our use cases. And then the data is going to hold all of our data interfaces. Like in this case, we're going to be using Retrofit, and then we're also going to be using a room database. So all of that is going to go within data. So to start off there, we're going to do new package, and we're going to say local.dto. So this local is going to be for everything that comes from our local cache, which is our room database. And then DTO stands for data transfer object. So when we're communicating with our room database or with Retrofit, we're going to be communicating in a format of our object that either Retrofit or room is going to understand, which is going to be slightly different than the format that we're using internally within our application. So that's what that is going to be. And then also within the data, new package, we're going to have, instead of local, we're going to have remote.dto. So same thing, remote is going to be for our Retrofit interface. And then DTO is, again, a data transfer object, which is going to be the format of the data that we use to send to Retrofit. And then also we're going to have a repository, which I'm just going to call repo for short. And then after repo, we're going to have another package in here for our dependency injection, which we'll call DI. And then after DI, we have another package for mappers. And basically what that is we're going to have our DTO in the local that we use with our room database. We have our DTO that we're going to use remotely with Retrofit. And then in domain, we're also going to have a data model. And we're going to need to be able to map our domain data model back and forth between our Retrofit DTO and our room DTO as well. So that mapper file is all the mapper functions are going to go inside of that. Now within your domain package, we're going to do new package, and we're going to have a model. You're also going to have a repository in here, and we'll talk about why you have a repo in the domain and also in your feature, or also in your data layer. And then after repo, we're going to have our use cases. So we'll have a package for that. I'm just going to call it use case. And then after, we're going to have one more package in here that we're just going to call util, which is going to be kind of a catch-all for any utility functions or classes or anything else that we need inside of our domain model. finally, we're going to have our presentation model. And inside here, we're basically going to have there's a couple different ways to do this, but in our app, I'm going to do a different package in here for every screen. So one is going to be our to-do list, which is that initial list that you see when you open it up. And then the next package is going to be our to-do new update, because we're going to share a screen for whether you're updating or making a new one. And finally, inside presentation as well, I'm going to have a util package, which is, again, just kind of a catch-all for anything that we need, any extra functions or classes or whatever that we need inside of our presentation layer. And then finally, the last thing I'm going to do within this package structure is I'm going to take main activity and I'm going to drag it inside of the presentation layer of our starting feature, which in this case is going to be our feature to do. Actually, within this core, I'm going to have another package. We'll do presentation there as well. And then inside of that presentation, we're going to do where I'm going to call this components. And down here in both of these, I'll put components packages as well. And that's just going to be for the small pieces of our application, of our UI, that we're going to build the larger screens out of. And then finally, up in this core, I'm going to put one more package, and that's going to be a util package again for the core. So I'm going to close all of these up for now. And you'll notice we have this UI package in here. And if I open that, I've got my theme. And then inside of my theme, I've got color.kt, which has a list of predefined color values. And then theme, which is a list of my, essentially the colors that I'm defining for my dark scheme and then my light color scheme. And this is all pre-generated code. So we are actually going to replace all of this. And the way we're going to do that is with the Material 3 theme builder that they put out online. So you can get it up at this URL. I'll put that link down in the description below. And basically all you do here is you pick your core colors. So I'm going to set my primary color, and I'm going to set it just to my standard SkyFish logo blue color. And then the tertiary color, I'm going to set to a nice, probably a nice pale green. And then if I close that, now you can see this is this is all the colors and how they're going to look within my application. So I don't have to worry about what is going to all look good together. This actually builds out all the colors for me. So it gives me on my primary, how to write text on primary, my primary container, how to write text on that. And we've got all of these different colors that are already put together to look well together. And we've got the light scheme and then the dark scheme. So all we have to do now is come up here, click the export button, and I'm going to say Jetpack compose theme.kt, download that, and then once you have that downloaded, let's go ahead and open that, extract that, and then inside here you've got a UI and a theme, and you've got color.kt and theme.kt. So let's go ahead and open up one of these. So we're going to open that up just with a notepad, and you can see here the package. Obviously, I don't want that com example compose, but everything else I'm going to copy out of this file, and I'm going to go back into Android Studio. And I'm going to paste that into there, and that's going to be the color scheme that I'm using for my app. And then if you come into the theme, same thing, come down here and go back into, let's go back into there and grab the theme file as well. So UI, theme, and then theme.kt. I'm just going to open that up with the notepad here. And again, we don't want the package. I'm going to copy all of this And then back in Android Studio, we are going to replace all of this with what we just copied. And app theme, I'm going to change that back to do theme, which is going to be the theme that was auto-generated when I named my project to do. And now this is going to have all the colors that we need to build our UI and make it look good together when we do that. Now that we've got our theme and colors all set up, one more thing I'm going to do here is come down into my res. If we right click and do new and add a new image asset, I'm actually going to upload an icon for this app right now. And I've got this icon that I created in GIMP, which is again on the GitHub page, so you can grab it from there, or you can make your own icon, or you can just go to Google and find your own and download it. And basically I've exported this icon, which is a 512 by 512 image. So I'm going to find that image that I exported, which I put in just this temp folder here. So we're going to pull that in, and then there's my image. You can see that it's made a legacy icon, a round icon, a Google Play Store icon, a circle, a squircle, a rounded square, every icon that we're going to need, depending on where it's showing up and what type of phone we're using, is already there. So if I hit next, and you'll notice I actually left this name as IC Launcher. You can technically change it to whatever you want, but because IC Launcher is already defined in our manifest file, I'm going to leave it there so I don't have to bother changing that. Hit next and then finish. And now that's it. We've got our color scheme set up, we've got our package structure set up, and we have our icon uploaded for this project. If you've made it this far into the video, congratulations, you've actually made it to our first checkpoint just after the setup. So you can grab all of the code down below for this last portion off of our GitHub using the Checkpoint 1 GitHub that we have in the description down below. And if you're just joining us because you don't like doing setup, that's fine as well. You can go to that same GitHub page and download all of that code with the package structure set up and with all the dependencies and the color scheme in place, and then continue on from here in the video. Now let's go ahead and start populating our data class. So open up data, and I'm going to start with local, which is going to be our room database. And the first thing that we're going to need for a room database is actually our data transfer object, which is going to act as our entity for room as well. So come in here and do new Kotlin class or file. And this is going to be a data class. And I'm just simply going to call this local to do item. And I'm going to add all of these to get every time. And above this, we are going to annotate it with entity. And then I'm going to define the table name, which is going to be equal to do in this case. If you don't define the table name, this is optional. It's just going to default to the class name, but to do is just a lot shorter and easier. So that's all I'm going to do in there. And now inside of here, we're going to need a few different variables to keep track of our to-do item. The first, we're going to need a title, and that's going to be a string. Then we're going to need some description of the to-do item. So I'm going to call that description, and that's going to be a string as well. And then I'm going to need a timestamp, and this I'm actually going to store in a long. We're going to need a variable to track whether this is completed or not. And that is going to be a Boolean. And then finally, I'm going to, well, not finally, one more Boolean I'm going to need is going to be for if it's been archived or not. And then we're going to need an ID. And Room is going to require that we tell it what our primary key is. And this ID here, we're going to use for our primary key, and also our unique identifier when we get to retrofit. But we're going to call that primary key, and we're going to set auto generate equal to true. So this is all that we need for our local to do item. Now let's go ahead and make our DAO. So inside that local data package again, new Kotlin class or file, and we're going to call this one our to do DAO. And this is going to be an interface this time, and DAO stands for Database Access Object, by the way. Annotate that at DAO, the room annotation there. And inside this to do DAO interface, we are pretty much going to put all of the different queries and they're functions that we're going to need to access and store and retrieve data out of our room database. So to do that, you start by query, but make sure to get the androidx.room. We don't want this retrofit one right now. We want the room because we're working with the room database. And after the query, we have to actually hand it the query that we're using. So this first function is going to be for getting all of our to-do items out of our database. So to do that, we can just do select asterisk, which means all, from to-do. So this to-do is going to be our entity database. So if you remember looking back here, our table name is to-do. So that's what we're matching there. And now after I've got that query, I need to tell it what function this query belongs to. So in this case, we're going to say fun get all to-do items. And this is going to return a list of local to-do items. And make sure to import that. Next, we need a function for getting a specific item out of our database. So again, at query, and this is going to be select asterisk for all from to do where ID is equal to the ID that we're going to pass in. And then this is going to be a suspending function, and we're going to call it get single to do item by ID. And then ID of type int, which we're going to map to which we're going to pass back a local to-do item, and it's going to be nullable in the event that we can't find a to-do item that matches that ID. And then after that, we need to essentially what we're going to do when we launch our app, we're going to read all of the to-do items in from our online database, and then we're going to write all of those to our local cache. So to do that, I'm going to have a function here for adding an entire list of to-do items. So we're going to say at insert, again from androidx.room, and this is going to be on conflict strategy, and I'm just going to say if they're the same, it's got the same ID, just replace it. And this is also going to be a suspending function, and we're going to say add all to-do items to-do. To-dos is going to be my list, and this is going to be a list of type local to-do item. And then after that, we are going to need a function just for adding a single to-do item, because if we click the add item button, we don't need to add a whole list or even just a list of one. We want to add just a single item. So again, at insert, and we're going to use the same thing, on conflict strategy equals replace. And then this is also going to be a suspending function, and we're going to call it add to do item. And it's going to take one to do of type local to do item, and it's going to pass back a long. And that long is essentially going to be my ID that Room assigns to this item. And we'll use that later. And then finally, we need the option to delete these as well. So at delete, and this is going to be suspending function, delete to do item, to do local to do item. And that's pretty much it for the DAO. Now we just need the database. We need to actually set up the database that we're going to be using here. So come back to local. We're going to do new Kotlin class or file. And this one I'm going to call to-do database. And this database here is actually, this is going to be an abstract class. And we need to annotate this with our database annotation from Room. And then inside here, we need to tell it what tables we're going to have actually inside of our database, what entities we're going to use. So entities equals And this is going to be an array, which is going to be just a list of all the entities. But here we really only have one, so it's going to be local to do item class. And this again is that entity annotated class that we created for our DTO. After that, version is going to just be equal to 1, and export schema, I'm going to set that equal to false. Now, inside of here, we're going to need a reference to our DAO. So abstract val DAO is going to be to do DAO. And then I'm also going to have a companion object down here. And this companion object is going to be const val. And this is actually going to be my database name. And here, I'm just going to set that equal to do db. And there's one more thing we need to do here, or this is not going to work. We need to actually inherit from our room database class here. So now with that database, we actually are not quite done with the local data. That's all we're going to put inside of our local data package, but we need to come into our dependency injection because we're going to be injecting this to-do DAO and also the database using Dagger-Hilt. So we need to tell Dagger-Hilt how it can do that. And to do that, I'm going to make a new object in here, and we're going to call this our to-do module. And this we're going to annotate for Dagger-Hilt. We're going to annotate this with the @module. And then we're also going to annotate this with the install in singleton component because we want this to be a singleton. And now inside of this to-do module, I need to essentially create all the functions that tell Dagger-Hilt how to provide instances of these classes, in this case, the DAO and the database. So to do that, I need to do the provides annotation. So there's the Dagger-Hilt provides, and this is going to be fun provides room DAO. And this is going to take just a database object of type to-do database, and this is going to return a to-do DAO. And now inside here, all we're going to need to do is do return database.DAO. And that's all we need for the DAO. But for the database, we're going to do something similar. So @provides, and then in here, we're going to say fun provides room DB. And because this is a room database, we want this to be a singleton as well. So I'm going to mark this class as a singleton. And now inside of here, I need an application context. So I'm going to say @application context of app context type context. So we pass that in as a parameter. And then inside of here, actually, before we go inside of there, we need to specify a return type. And of course, this is providing our room database. So our return type had sure better be our to-do database that we want to provide to our application. So all we need to do is do return and then do our database builder to actually build our database. So we're going to return room.database builder. And now inside of this database builder, we're going to hand it our app context.application context. And then we need to hand it our to-do DAO. So, or sorry, not our to-do DAO, our to-do database class. So to-do database class.java. And then after that, we need to hand it the name of our database, which if you'll remember in our database class, we named it to-do database. So in here, we're going to say to-do database. And finally, after this, we're going to say dot fallback to destructive migration dot build. So now we are totally done with the room database, the entity, the DAO, and the module functions that we need for Dagger-Hilt to provide those using dependency injection. And now you've made it to our second checkpoint. So if you've made it this far, be sure to like and subscribe to our channel to continue getting additional content like this that's going to be beneficial for you. And if you're just joining us, again, you can now grab the code to pick up from this point at our GitHub down below in the description. So with everything in our local done, it's time to start looking at our remote data here. And I'm going to start with the DTO again. So to do that, I'm going to come to my local to-do item, and I'm just going to copy this without the entity, and then come back over to remote DTO. We're going to do new Kotlin class or file, and this is going to be a data class. And we're going to say remote to-do item. And I'm just going to paste all of that, change this local back to remote, and then get rid of this primary key because we're not using room anymore. So get rid of that import statement as well. And now here is our remote to-do item, but we need to actually pull this data from somewhere. So to do that, what we're going to do is we're going to use Firebase online, and here it's just console.firebase.google.com. You can easily find that, or I'll put the link down in the description below. But what I'm going to do, I'm going to add a project, and we're just going to call this to do, continue. I don't need the analytics for this project because really it's only going to be me that's going to be using it. It'll take just a minute to create that project. And what we're going to do is we're going to build a real-time database inside of our Firebase console in this new Firebase project. And then we're going to use our retrofit to treat that database that we're hosting a JSON file, just like we would any other JSON online. And we're going to pull that data into our app and write back to that data as well. Now, what we're not going to do in this video, we're not going to authenticate with Firebase, and we're not going to use all of the built-in Firebase functionality and plugins and dependencies that go with Android Studio, because the intention here is we want to show you how to use Retrofit, not necessarily Firebase. So we'll do Firebase in a future video. Now that that project's done, click continue on that, and it'll take you here. Basically, we're going to come to build. We're going to go down to real-time database. Once you get here, create a database. And you can really put this in whatever zone you want. I'm going to leave it in the United States. And we're going to start in test mode, actually, which is going to give you read from now for the next 30 days and write from now for the next 30 days. And not just to you, it's going to give that to anybody. But that's fine because I want to be able to read and write from this database, and we're really only going to be using it right now for this app. So it's not going to be a huge vulnerability if somebody were to hack this database. So enable that. Once we have that loaded, we're actually going to need some data to put into our database. We could do that through our app because we have that add feature. But what I like to do is just add a bunch of data up front so that once we open the app, there's data to play around with and mess with, and we can test some of the other functionality before we get to the point where we can test the add feature. So to do that, I am just going to go to ChatGPT here, and I'm going to say new chat, and I'm just going to paste in this prompt, which is basically, can you give me a JSON of 30 tasks in this format with a fall theme? Fall being, this is just early October, and I thought that was fitting for this video. So we're going to go ahead and hit enter on that. And then ChatGPT is going to give me a JSON file that we can then upload to Firebase and then pull down to our app. And you can see here it ended, so click continue. And while that's going, let's go ahead and actually grab all of this top code, this top JSON. So bring up a notepad. Then I'm going to paste all of that into there. And it should be done with the rest of that. So we left off on item 24, which means I can pick up right here with this. Yeah, right there. It ended right in the middle of the sentence. So grab all of that. and then come back to our notepad. And now we have a JSON file that we can go ahead and upload. So I'm going to save this file, save as, and this one I'm just going to simply stick in that temp file that I had on my C drive. To do dot, and don't do a text file, you want this to be a .json file. Make sure to change the save as to all files and hit save. Now, if we come back to Firebase, we can simply import that JSON using this import JSON function here. But before we do that, I'm going to add just a to-do key down here, and that way it's just going to give me one more level. So if I need to delete this, I can just delete this instead of having to delete all 30 of them individually. So click in that new one that you created, click on the dots, import JSON, browse, select that new to-do.json file that we just generated from ChatGPT, import that, data imported successfully, and here you go. So here's that first one that I added, and then here's all the rest of them that ChatGPT added. So now, if we were to copy this reference URL and go to a new tab, and then on the end of this, just type todo.json. Well, here we've got the JSON file that we need to read in. So this is what we're going to interact with using Retrofit with our application now. Now that we have that back in this remote to-do item, we need to add a few things. The first thing we need to add to all of these fields, you'll notice if we look in our JSON file that we just created, so for example here, archived, capital A, completed, capital C, description, capital D, but if we look back in here, we've got all lowercase letters. So we need to tell Retrofit how to map this field to the field on the Firebase database that has a different title. And the way you do that is with the @serialized name annotation. And then inside of there, we're just going to need to pass that the name for the field, the corresponding field in that database that we created. So I'm just going to copy that and stick that on all of these. Now, in here, all we need to do is put the fields that we used for that JSON file. So title, description, I think they're all the same, but just with capital letters, timestamp, completed, archived, and finally ID with both an I and a D capitalized. So that's really going to be all that we need for the remote to do item. Now what we need to do is build our API interface. So in the remote package, right click, new, and we're going to do a Kotlin class for file, and this is going to be an interface. And this interface I'm just going to call to do dot in this interface, I'm just going to call to-do API. And now in here, just like we did in our DAO, how we had all of these select from functions, and those are all the functions that we use to interact with our local room database. So in this API, we're going to have all the functions that we use to run our HTTP requests. So in here, we're going to do @get and make sure to do retrofit here. So get, and this is going to be to-do.json because again, that was the name of at least the last part of our endpoint that we're going for. And this is going to be a suspending function, get all to-dos. And this is simply going to return a list of remote to-do items. Then next, we're going to need to get a single item by ID, just like we did with the database earlier. So we're going to do get, and then this is going to be to-do.json again. But this time we're going to say order by equals, and here we're going to do it with a backslash quotes just to escape that, ID, and then backslash quotes again to escape it. And then down here, this is going to be another suspending function. And this is going to be, I'm going to name it get single to do by ID. And that's going to be a query, which is going to be, make sure to get the retrofit query, and that's going to be equal to, and then after that, ID, because we want it where the ID matches, because we're getting it by ID. And then this is going to actually return a map. And inside of that map, we're going to have a string and then a remote to-do item. Okay, so that one looks good. Now we need to do our, what would normally be a post function. So I'll show you what that would look like, and then I'll show you actually what I'm going to do instead, because with Retrofit and Room, we're going to do this just a little bit differently. And what this would typically look like is you would want an app post and import that guy. And then in here, we're going to have our endpoint again, at least the end of it, which is to-do.json. And then finally under that, suspend function. And this is going to be add to do. And inside of this add to do, we're going to do an at body URL, which is of a type string, and an at body. This is, I'm going to call this updated to do, which is, of course, going to be of type remote to do item. And this is going to hand back a response of type unit, I believe. So let's import that one. And this is typically what you would do, because when you're adding an item, that's a post command, and not usually, you don't usually use a put for that. You can, and we're actually going to, because if I run it like this, Retrofit is going to automatically generate a unique identifier or a unique key for this item. But we already have a unique key, and we know it's unique because we're using Room to generate the unique key here, and that's our ID field. So if we look back in our local DTO, we have this primary key and it's auto-generating it. So these are going to be unique because it's auto-generated by the Room library. And because of that, I don't want a unique key for Room and also a unique key for Firebase, because the Room unique key is going to be just a, I believe, an integer, or maybe a long. Yeah, it's going to be an integer. And then the Retrofit unique key is a big long string of characters that's just really difficult to work with. So I don't really want to generate that. So instead of doing this post command, I'm actually going to do an add with a put command. And to do that, all we're going to do is say at put suspend fun add to do, and then this is going to be at URL, URL, which is of type string, and then at body updated to do, which is going to be a remote to do item. And then this is also going to return a response of type unit. And make sure to import that right one. So this is actually what we're going to use for our add to do. And now we need two more. We need one for deleting a to do item, and then for updating a to do item that's already in there. So for a delete, we can just go at delete, and let me just keep it consistent. At delete, and then in there, we're going to hand it a to do slash ID dot JSON. And basically what this means is, you remember we separated it initially with that to-do item that we added, but now we're going to go by ID, because as we build these out, we're going to be using that ID that we're generating from Room to access every individual JSON. So if we look in the JSON that we uploaded to Firebase right now, you can see each one of these, we've got our top level endpoint, and then we have our to-do, and then we have a integer. So if I were, for example, to come over here, and instead of doing todo.json, I do todo/5.json. It gives me only a single item out of there, which is going to be enjoy a scenic hike through the countryside, go on a hike. So if we come back to our real-time database now and look at number 5, you can see that one is actually go on a hike. So this ID here, which is also the name of this entry, is the ID that we need to match for the delete item. So that's where we're pulling that ID.json from. And then down here, all we need to do is do a suspend function, and we're going to do delete to do, and this is going to be at path ID, and this is going to be ID, and it's going to be a nullable integer, which is also going to return a response unit. And then finally, we just have one more command to put in here. That's at put, and again, to do /id.json, because if we're adding one, we want to add it with the same format that we already have, which is building them off of that ID field as the identifier. And this is going to be suspend function update to do item, and we're going to do at path, and inside of there we're going to say ID, which is again going to be a nullable int, and whoops, not like that. It's going to be a nullable int, and then after that we're going to say at body to do item, which is of type remote to do item, is then going to return a response of type unit. So this is all that we need for our API here. But again, we're not quite done because we've defined all of the functions for our API interface, but we need to actually tell Dagger-Hilt how to provide all of these. So I need to go back into my to-do module in here, and I need to do basically another function down here for providing our interface. So we're going to say this is going to be a singleton again, because we only want one instance with our retrofit database. And this is going to be at provides fun. I'm going to say provides retrofit, which is going to provide the instance of our retrofit option, the instance of our retrofit object, which is why we're going to return a retrofit object here. And then we're going to say return retrofit dot builder. And then after that, we're going to say dot add converter factory. And inside of that converter factory, we need to use that JSON converter factory that we have with retrofit down here. So JSON converter factory dot create. And then after that, we just say dot base URL, and we need to hand it our URL. So we'll go grab that from the internet in a second. And then we say dot build. So this is all we need, except we need to grab that URL. So if we go back to Firebase and come up to the top level here, all we need to do is click this copy reference URL button here, and that should copy it to your clipboard. And then you come back into here and paste it. And you don't want to use mine. So you're really going to want to use your own, because like I said, I put this real-time database in test mode, which means it's got open read and write access. But after I'm done filming this video, I'm going to turn that off. So you won't actually be able to access this endpoint. You need to go to Firebase and create your own real-time database that you can use. Okay, now one more thing. We've got a retrofit instance, but we needed to provide that API as well. Because we're also going to be passing that API in as a dependency. So we can say at provides, then fun provides retrofit API, and this is going to be a retrofit. We're going to take retrofit as a parameter, and we're going to return a to-do API. And then down here, all I'm going to say is return retrofit.create to do API class.java. Okay, so with Retrofit now set up and finished, we can go into our domain layer, and in here in the model, let's go ahead and actually create our to-do item class. So new Kotlin class or file, and this is going to be a data class, and we're just going to say to-do item. Now open up remote to-do item, copy all of this, and come back down into to-do item, paste all of that, delete the remote, and then delete this import. And then basically we have to delete everything that's red in there now. So all of these serialized names, because we don't want any of the third-party dependencies in our domain layer. We want those only in the data layer. Now with that to-do item, I'm going to add one more piece of information, and I'm going to put that down in the util class in here. So I'm going to say new, and this is going to be a Kotlin class or file. And this is going to be a class that I call invalid to do item exception. And this is pretty much going to be for if when the user is making or updating a to do item, if they leave the description or the title blank, then we're going to have this error exception class that we can throw. And in here, I don't need the body. All I'm going to do is inside my constructor, I say message, which is going to be of type string, and this is going to inherit from exception message. Okay, so that's all that we need for that. Now that we have our data layer model, which is our to-do item, and then we have our local to-do item, and we also have our remote to-do item, let's go ahead and make those mappers that we need so that we can map back and forth between these. The new Kotlin class or file, and this is going to just be a file, and I'm going to call this to-do mapper. And now in here, we're basically going to create a bunch of extension functions for these data classes that we can use to map them back and forth between one another. So in here, I can say fun to do item dot to local to do item. And this is going to turn back a local to do item, obviously. All we're going to do in here is say return local to do item, and then inside here title equals title, description equals description, timestamp equals timestamp, and then completed equals completed, archived equals archived. So all we're doing here obviously is just mapping every field to the corresponding field in the other object. So now that we have that, we've got to-do item to a local to-do item. Let's do that to a remote to-do item. So copy that, type remote, and then same thing here. We're going to return a, whoops, that's not right, a local remote item. That's not what we want. We want a remote to-do item. And go ahead and import that class. And then down here, local to-do item, we need to change that to remote as well. So that's everything from to-do item to local, and then to-do item to remote. So now let's copy that again. And down here, we're going to paste that, and we're going to do a local to-do item to-do item. And this is going to pass back a to-do item. So return to-do item. That's all we need. Copy that one more time. Down below that one now, we're going to say local to-do item dot to remote to-do item. And return a remote to-do item there, and make sure to update it down here as well. So now we've got local going to both of them. So now we just need remote going to both of them as well. So paste that down here, and this is going to be a remote to-do item to a to-do item, and then we're going to return a to-do item, and again return a to-do item there. I know this is kind of repetitive, but that's why we're putting all of these in this file, so we can write it, get it out of the way, and be done with it. So now we have one more. We have remote to our domain to-do item, and now we need our remote to our local to-do item. And then we're going to return again a local to-do item. Okay, so now we have all of the mappers that we would possibly need for mapping all of these, the DTOs and the data layer back and forth between each other, and then between the to-do item and the model layer as well. But because we're going to be working with lists in this program, I'm also going to create some extension functions for the lists that we're going to be mapping back and forth as well. So down here, I'm going to say fun lists to-do item dot to local to-do list item. And this is going to be list local to-do item. We're going to return a local to-do item list. And then down here, we're going to say return this dot map to do. And then in here, all we're going to do is copy this local to-do item from up here, paste that down here, and instead of saying title, now we're just going to do to-do.title, to-do.description, to-do.timestamp, and so on. So to-do.id, archive, completed, timestamp, description. Okay, so that's basically what this is going to look like. I'm going to copy that whole thing. And then same thing down here. Now, instead of going to a local, we're going to go to a remote. And then same thing here. This needs to be remote. And finally down here, this also needs to be remote. And now we've got our to-do list, our to-do item lists going to local and remote to-do item lists. But we need also our local and remote ones going the other way. So in here, I'm going to say list to-do item. This is actually going to be a list of local to-do items. And what we're going to do is we're going to say local to-do item dot to to-do list. What did I do here? To-do list item. Let's update this. I did not name these right. So dot to local to-do item. That's fine. But here we have list dot to local to-do list item. So we don't want that. We want dot to local to-do item list. And then same thing here. Get rid of the lists there. Put it on the end there. Same thing here. Get rid of that and put it on the end. So this is a list of local to-do items dot to-do item list. And this is going to be returning a list of to-do items. But also on the end of here, I'm going to make this a little more specific. So this is to-do item list, and I'm going to say from local. And the reason that I'm adding a from local here is because for the extension functions for list in Kotlin, it's not going to see list plus the return type. Instead, what it sees, it'll see list any. And if it sees list any, and we've got dot to do item, dot to local to do item, and then dot to remote to do item, when it actually converts this down and runs it through the JVM, we're going to get duplicate JVM signatures. So because of that, I'm going to add from local to anything coming from a local, and then from remote to anything coming from a remote. So we've got our first one here. I'm going to copy that, paste it again, and now this is going to be a local to-do item to remote to-do item list from local, and this is going to return a remote to-do item. And then this same thing here is going to be a remote to-do item that we're passing back down there. Okay, so let's copy these two, and then we'll be done with mappers after this. I promise you, I know this is repetitive and not exciting at all. So local to-do item, we're going to change to a remote to-do item. We're going to say to-do item list from remote. And this is going to pass back a to-do item list, and that's all we need to do there. And then down here, we're going to say, change this local to-do item to a remote to-do item. And then we're going to say, instead of to a remote to-do item, we're going to say to a local to-do item from remote. And then this is going to be a list of local to-do items. And then down here, finally change our remote to-do item to a local to-do item. Okay, so that is all that we need to do with the mappers. We have all the mappers that we need for the individual to-do items, remote and local to-do items, and then our domain model as well. And then we also have all of the mappers that we'll need going back and forth between any lists of type to-do. If you've been following along so far, great job. We've now made it to the third checkpoint. We've just finished up implementing all of our remote package, and we've done our domain model and also all of the mapper functions for that as well. So that's going to be super helpful. Hopefully you're learning a lot in this video, and definitely punch that like and subscribe button down below and leave a comment telling us what you think, what we can improve. And if you're just joining us now, you can grab the code for this point in the video in the link in the description down below for the third checkpoint. Let's go ahead and finish out our data layer by adding the repository. But before we do that, we actually need to go and add our repository in the domain layer. So that's going to be a new Kotlin class or file, and this one is actually going to be an interface. So I'm going to call this to-do list repo. And then in here, we need to put all the functions that we're going to need in our repository, obviously. So suspend function get all to-dos. And this is going to return a list of to-do items. Let's make sure to import that. And then we're going to do suspend fun get all to-dos from local cache, which is also going to return a list of to-do items. And then I'm going to do suspend fun get all to-dos from remote. And this is actually not going to return anything because we're just going to use this function for updating the local cache and not for actually updating our state or anything on the screen directly. And then I'm going to do suspend function get single to-do item by ID. And this is going to take in an ID parameter of type int. And this will turn back, this will return one to-do item, which will be nullable in the case that that ID doesn't exist in our database. And then after that, we're going to do suspend function add to-do item. And that's going to be to-do item. And then after that, we need our update to-do item. Again, it's going to have one parameter to-do of type to-do item. And finally, suspend fun delete to-do item. So most of these are pretty self-explanatory what they do. They don't need a lot of explanation here. So that is really all that we need inside of our repository interface. But now if we come up to our data layer, we've got this repository package up here. So what we need to do is do a new Kotlin class or file. And then in this data layer, we're going to do a class, and we're going to call this to-do list repo implementation. And in here, we're going to inherit from our to-do list repo. And now that's obviously going to give us an error because we have to implement the members. So let's go ahead and do that. And we'll go back through in a minute and replace all of these. But before we get into that, I want to just real quickly touch on why we have this interface in our domain layer, and then we have this implementation in our data layer. So what's going on here is when we're finished with our app and it comes time to test the app, our repository implementation in the data layer is going to be very heavily tied to our API implementation and our database implementation. So in this case, it's going to be heavily tied to our Retrofit instance and then our Room database instance. And if we run testing with Retrofit and Room database actually running, then we're going to have some pretty serious problems with that because it's just going to be way too inefficient, and we really don't want to be doing that. So it's gonna slow down our tests way too much. So what we're gonna do later, if we ever get to testing this app, what we're gonna do is we're gonna create a dummy implementation or a mock implementation of this repository class, and then we can test everything in our domain layer and also in our presentation layer without actually having to rely on our repository that's tied to our Room database and also tied to our Retrofit instance. So let's get going on that repository implementation class then. The first thing that we're going to need to do in there is actually provide a constructor. So up here, we're going to need to pass in some dependencies. So first, we're going to do a private val DAO, and that's just going to be our to-do DAO. And then after that, we're going to do private val API, and that's going to be our to-do API. And then after that, we're going to do private val dispatcher, and this is going to be a coroutine dispatcher, but this one here is actually going to give us a problem because this dispatcher, Dagger-Hilt, doesn't yet know how to provide that. So we need to tell Dagger-Hilt how to provide that. So to do that, I'm going to come up here, and in my dependency injection folder, we're going to do a new Kotlin class or file. I'm going to insert an object, and this object I'm just going to call my dispatcher module. And if you've seen some of my other videos, you may have seen this dispatcher module before. But basically, what we're going to do is up above this, we're going to put at qualifier, and then we're going to say at retention, and this is going to be an annotation retention binary. And then inside here, I'm going to say annotation class, and this is simply going to be our IO dispatcher. And now we have this new IO dispatcher annotation that we can use. So, well, we're about to at least. Down here inside my dispatcher module, I need to give it a provides. So I'm gonna annotate this at IO dispatcher, and this is going to be at provides, and then I'm going to say fun provides IO dispatcher coroutine dispatcher equal dispatchers.io, and then make sure that you get all of the right things imported. And that's all that we need in here. We'll visit this file again later when we need to do the main dispatcher, but we can go back to the repository implementation for now. And in here, what we need to do is we need to add that new annotation that we just created. So at IO dispatcher. And basically what this is going to allow us to do is use a different dispatcher for in our repository for when we're actually running our application versus when we're testing it. And that's going to be very important down the line if and when we get to testing of this application. So now from here, we need to start implementing these functions. So let's start with kind of the low-hanging fruit ones first, the easy ones. We'll get those knocked off and then do the rest. So get all to-dos. This one is actually going to be pretty easy. All we have to do is say get all to-dos from remote, which is a function that we haven't defined yet. And then we're going to say return DAO.get all to-do items. And of course, we're going to run into an issue here because we have DAO.get all to-do items and you have a type mismatch. Because we have a list of to-do items and, well, actually, we're supposed to be returning a list of to-do items, but what we're actually returning here is a list of local to-do items. So luckily, we spent all that time building all of those mapper functions. So we can say to do item list from local. And that's all that we need for that function. We do need to go find this get all to-dos from remote and do that one. But that function is going to be a little more complicated, so I'm not going to do that yet. Just take for granted that that's going to do exactly what it says, and that's pulling in all of those functions from the remote database, which is our Firebase real-time database. And we're going to do that using Retrofit. So next, we're going to go ahead and do so get all to-dos from local cache. That's going to be an easy one to do here. All we have to do is return DAO.get all to-do items to-do item list from local. And there we go. Again, easy because of those mapper functions that we wrote. Let's see. Let's keep going with these easy ones here. We're going to do update to-do item. So DAO.add to-do item, and we're just going to say to-do dot to local to-do item, and then after that we're going to say API dot update to-do item, and the ID is going to be to-do dot ID, and then to-do dot to remote to-do item, and then after that we can do our, let's see, get a single to-do item by ID. This function is also going to be pretty easy. All that we need to do here is say return DAO.get single to-do item by ID. And basically we need to pass it our ID that we're passing into this function. We need to basically do a to-do item. Now we've knocked out all of the kind of the one-liners here. Let's go ahead and do this add to-do item. So in here, all we're going to need to do is say val new ID is equal to DAO dot add to-do item. And I'll explain this in a second here. So to-do dot to local to-do item. And basically what we're doing here with this new ID variable is this DAO.add, our database access object, is adding a new to-do item to our local database, and the return here is going to be the new ID that was auto-generated. So if you remember in our local to-do item, we've got this auto-generate equals true for our primary key, which is our ID. So now back in our to-do list implementation, this new ID is going to be essentially this unique ID that was generated by Room Database. Now that we have that, I'm going to use that new ID to write it to our retrofit instance as well. So I could say val ID equals new ID dot to int, because we're using integers for that. And because this is a to-do item list, I'm assuming we're never going to overflow our integer value here, even though that is actually coming back as a long. And we're going to say val ID equals new ID dot to int, and then we need a URL here. So val URL equals, and this is going to be to-do /$ and then ID, which is that ID that we just got back from Room, and then .json. And then once we have that ID, we can go ahead and write this item to our to our real-time database out on Firebase as well using Retrofit. So API dot add to do, and all we need to hand this is our URL, and then to do dot to remote to do item, and then we're gonna on this we're gonna say to do dot to remote to do item dot copy, and then we're gonna say ID equals this new ID value that we got in here. So this is going to add a new item to our local cache, take that new ID that the local cache room database created, and then create a new item in our real-time database up on Firebase using that new ID that was created. Let's go ahead now and do this get all to-dos from a remote function. So the first thing that we need to do is return with context and then hand it that dispatcher that we sent in. And again, we're doing that dispatcher as a dependency up here in the constructor, because that way we essentially were able to use a different dispatcher for our test versus for our actual running. So that's going to be beneficial when we get to testing. Right now, inside here, basically what we need to do is pull all of the data down from our remote real-time database using our API, and then store it in our cache. And then we can pull the data out of that cache. So to do that, we're going to say try. So we'll have a try catch block here to catch any errors that we might get. And I'm just going to call this E exception, and then inside that catch block, we're going to have a when E, and we're going to handle all the network errors that might come up. So is unknown host exception, is connect exception, is HTTP exception. Then we're going to go ahead and just write to the log and say log.e. Make sure to import that log function here, and also import with context while you're at it. Inside here, I'm going to say HTTP for the tag, and we're going to say error, no data from remote. And then after that, I need to check if my cache is empty. So to do that, I actually need a function to check if my cache is empty. So just below this function, I'll make another one down here, and this is going to be private. Private fun is cache empty. And that's going to just pass back a Boolean. And all that needs to do is var empty equals true. So we have a variable to track if it's empty. We're going to set that equal to true initially. And we say if DAO.get all to do items dot is not empty. Then we're going to say empty equals false. And then after this, all we need to do is return our empty variable. Now, up in this if statement, we can say if is cache empty. Then we're going to do another log down here, and we are going to say cache for our tag, error, no data from local room cache. And then I'm going to throw an exception down here, throw exception, and then inside that exception, I'm going to say error, device offline, and no data from local room cache. So this, later on when we get to the UI, this error that we throw back is actually going to be displayed on the screen if we run into this error scenario here. And then after that, we're going to say else throw the exception if it's any other type of exception. But now up here in the try, we have to actually try to make our call. So to do that, again, what we're doing is we're using our API to pull the data in from our from our real-time database using our Retrofit instance, and then we're going to dump that data into our room cache, and then we're going to pull the data out of the cache. And that's why this error down here, if you get one of these exceptions and the cache is empty, then you get this error that our device is offline and we don't have any data in the local cache. So what we need to do in this try is basically we need to update the room database cache using our Retrofit instance. So to do that, I'm going to make another private function down here. And I'm going to say private suspend fun refresh room cache. And inside this function, what we're going to do is we're going to say val remote books equals api.get get all to-dos. And right here, I'm just going to say dot filter not null, just to filter out any null items that might be in our database at any point. And then I'm going to say dow dot add all to-do items. And inside here, I need to pass it my remote books. And then we're going to do 2 local to-do items from remote using, again, that mapper function. And now all we need to do is take this refresh room cache and come up here and stick that inside of our try block. Now with that in place, we're done with that. We just have one final function in here, and that's going to be our delete function down here. So inside of this delete function, again, we're going to do a try catch just to do any error handling in here. And I'm going to catch exception E again. And then inside here, we're going to, let me just find that last one and copy all of this. We're going to do when E is any of these network exceptions, because we're still, again, working with our Retrofit instance. So there could be some network issues in there. So when it's a network issue, then we're going to just write to the log.e, and I'm just going to call this HTTP again for the tag. And then the error is going to be error could not delete. Could not delete. Man, I can't spell today. Okay, and then down here, we're just going to say else, meaning if it's not one of these 3 HTTP network errors, then we're just going to toss E. Now up here in the try, we have to actually perform our delete. So what we're going to do is we're going to say val response equals api.delete to-do item. And then in here, we handed our to-do.id, which is that to-do that we're passing into the function. And now that we have that response, we can say if response.is successful, meaning if this function succeeded in what it was trying to do in deleting the item, then down here, I'm just going to write a log. And technically, you don't even need this part, but I'm going to put it in. So we're going to say log.i API, this is in my delete, so I'll say API delete, and then I'm just going to say response successful. Now we're going to copy that log statement. After here, else, in here, paste that log twice. On the top one, I'm going to change response successful to obviously response unsuccessful. And then the second message, I'm going to change it to response.message. And that way, if this response does come back with some issue or some error, we will see that in the log and we won't have to worry about hunting that down again and trying to figure out where that goes. So before this is actually going to work, there's one more thing that we need to add to our application here. And that is if you come on up into your manifest file, we need to add our internet permissions up here because we can't obviously make any HTTP calls if we don't have internet permissions turned on. So right here, we could say uses permission, And then this top one, internet, close out that tag, and that should be good to go. We should be totally good with our entire data layer. So I'm just going to close that for now and we can move on. If you've been following along in this video so far, well, you've now just made it to the fourth checkpoint. We've just finished up our data layer entirely with our repository implementation, and now we're ready to move on to the use case, which is going to handle all of our business logic in the domain layer. So if you're just joining us, you can feel free to grab that code from the description below, and definitely make sure to leave a comment below letting us know what you think and if this is helpful for you, and then subscribe to our channel as well. Now that we've finished out building our data layer, let's go ahead and finish out our domain layer as well. So in the domain layer, you need two things. The first is going to be your model, which is our to-do item, and that's totally done. And then the second thing that you need is to put all of your business logic. And we're going to use use cases to run all of our business logic. So that's what this use case package here is for. So basically any interaction that the user has with the screen, we are going to want to encapsulate into a use case here. So if you look at this screen, there's a couple different things that I can do. I can click on this checkbox to either mark an item as done or not done. I can click on this little arrow over here, which is going to archive it, or I can unarchive it. I can click on this and edit everything. And keep in mind here that if I delete all of this, the title and the description, and then I hit save, I get a little pop-up here saying, hey, this is invalid. You have to have some content in your to-do item. I can also toggle whether it's completed or not from here, or whether it's archived or not, and I can delete it. And you can see I can delete it from here as well. And now you'll also notice I have this button down here to add a new to-do item. So I can add and update. And then I have in my menu, I have my sorting menu. So I can sort by title or by time or by whether it's completed or not. And because these are three, it's essentially a set of finite things, I'm going to represent the title, time, and completion with a sealed class so that then we can pair that with a when statement and be able to check that very easily. And the same thing with sorting up or sorting down. I'm going to have that be a sealed class as well. And then for whether we should display the archive data or not, you can see pretty easily that is just a Boolean because basically it's is visible is going to be either false or true. So that's how we're going to do all of that. Let's go ahead and jump right into that. So the first thing to do here inside of this util class, I'm going to make a new Kotlin cluster file, and this is going to be a sealed class, and this is going to be our sorting direction. So the options for this are obviously we can either sort that up or down. So within this sealed class, we're going to have two options here. So object up is a sorting direction, and then object down, and that's all that we're going to need here. Okay, so now with our up and down sorting direction inside of this sorting direction class, I can come back into my util, make another sealed class. So new Kotlin class or file, this is going to be a sealed class. And this one is going to be called to-do item order. And now in here, I'm going to need a couple different things. First, in the constructor, I'm going to need that sorting direction. So val sorting direction of type sorting direction, which we just made. And then after that, we're going to need the show archived, or whether or not we want the archived to-do items to be visible or not. Now this one we don't actually need a sealed class for because there's only two options here. So we're going to say val show archived, and that's just going to be a Boolean. And then within this class, we're going to have basically three different options here. We can sort by either our title, our time, or whether it's completed. So to do that, I'm just going to say class title, sorting direction, show archived, and then this is going to return a to-do item order. Okay, now let's go ahead and copy that whole field, that whole line. Paste that twice, and in here we're gonna have our title, our time, and then whether or not it's completed. And then finally, down here, we are gonna overload the copy function. So that's gonna be fun, copy, and this is gonna be sorting direction, show archived, and this one's gonna return a to-do item order. And then finally, inside of here, all we're gonna do is say return when this is title, then we're gonna return title, sorting direction, show archived, and then we can copy this again, paste it twice, and then we have our title. We need our time as well, and then we need our completed. So now this is all that we're going to need for our sorting menu, because we've got our to-do item order, and that's got basically the index that we're going to sort on, which is either going to be a title, a time, or a completed. And we've also defined a copy function for that. And then inside of here, we've got our show archived for whether or not we want the archive variables to be, or the archive to do items rather, to be displayed to the user. And we've also got our sorting direction, which is going to tell us whether we want to sort it in either ascending or descending value, which we called up or down. And just to be clear here, the reason that we're having a copy function inside of here is because we are going to be representing this to-do item within our state, within our view model. So because of that, when we update our state, we generally like to do .copy on that. And because this is a sealed class and not a data class, it's going to be very useful for us at times to be able to run .copy on this. So that's why I added that copy function down there. Now let's get into the use cases. So I'm going to do new Kotlin class or file, and we're going to call this to do use cases. Now, traditionally for use cases, at least one of the most common approaches is you're going to have a separate class for every single piece of functionality. So for each business requirement, you'll have a separate class to represent that. So for example, if we wanted to do add to do, you would make a new class here and say new Kotlin class or file, and we would say add to do use case. And because that's very specific, we don't need to worry about a function name. So what you do is you have a single class with a single function. So we would call it add to do use case, and then inside of there, you're going to put a fun invoke operator, and basically that means you have one function without a name that you can invoke, and you're going to do that from your view model. But because most of our use cases here are going to be fairly simple, fairly straightforward, I'm not going to do that because it can be really messy to have a lot of different classes for all of the different use cases. So another approach, and an approach that's good and also equally valid, especially for a smaller project, is to make one use case class, and then inside of that, for every individual thing that we need to do, we're going to have one function. So we'll have a function for add, a function for update, a function for delete, and a function for sort. So let's go ahead and do that. So like I said, instead of in here saying maybe suspend operator fun invoke, which is one very common way of doing use cases, and then putting whatever code you want for this specific use case in that function, I'm going to not do that. And we're going to have one function inside of this use cases class for each use case that we have. So before we can do that, we're going to need a constructor. And inside of that constructor, we need to have our repository. So private valve repo, and that's going to be a to-do list repository. Note that this is the interface, and this is not our implementation of that interface, because when it comes to testing, we're going to want to be a little more flexible than passing in the actual implementation. And then up here, because we're using Dagger-Hilt, we need to annotate that with @inject constructor. So inside of here, let's go ahead and add those functions that we'll be needing for each of our use case. So suspend, fun, add to do item, and this is going to take in a domain type to do item. And these are going to be mostly suspending functions because we're working with HTTP network calls and also with a room database. So because of that, they need to be suspending. And this should be actually fairly simple. All we need to do is say repo dot add to do item, and then we pass in that to do item. But there's one more thing that we actually need to do here, because if you look in here, if I click new and then click save, I get this little pop-up that says both the title and description must be filled in. So we need to add that in here. And basically the way that we can do that is I can say if to do dot title dot is blank, or to do dot description dot is blank. Then in here we are going to throw our invalid to do item exception that we created. And then inside of there, we're going to want to pass it that string, which said both the to do title and description be populated. And let me just make some of this capitalization a little more uniform. Okay, now I'm actually going to cut this string out of there because it's not a good practice to be putting strings directly in your code like that. What I'm actually going to do is up in my core package under my util, I'm going to do a new, and this is going to be a new Kotlin class or file, and this one is just actually going to be a file, and I'm going to call it to do constants, and this is going to be for all of the constants that we use throughout our project here. Now, obviously there's already a res strings XML file in here that you can certainly use for string constants if you want to, and that's just down here. You can find it in your res values strings.xml. You're welcome to put constants in there. And that's really good for when you're translating an app into multiple different languages, and then all you have to do is replace this one XML file instead of having to mess with any of the code. But because this is just a simple app and I'm not going to be translating anything, it's also a equally valid practice to go ahead and store constants within an object in a Kotlin file itself. So I'm going to put that under core util, and in there I'm going to make an object for my to-do use cases. So we're going to call this to do use cases, and we're going to put a new value in here, const val, and we're going to call this empty title or description, and set that equal to that string that we had. Now let's go back to our to do use cases, and when we throw that error, we are going to throw empty. Why is that not coming up? Okay, let's go back to our to do constants file. Let's copy that. We have, oh, I know why. Okay, so our object to do use cases, and then our use cases file is also named to do use cases. So we definitely don't want to do that. What we want to do is name this to do use case strings. And then back in here, we want to say to do use case strings, because obviously we can't have two different objects, one object and one class with the same exact name. That's not going to work at all. But here this should work. And this is all that we're going to need for our add to do item use case. Now down here for our update to do item use case, it's going to be actually quite similar. So down here, we're going to say suspend fun update to do item, and this is going to take in a to do, which is of type to do item with no return type on this. And we're going to say basically the same thing here, because if we're updating it and it's got a blank title or description, we don't want to allow that either. And then we say repo dot update to do item to do. So that's all that we need for the update. Then after the update, we have a delete to do item, suspend function delete to do item. And then again, in all of these, because we're in the domain model, we're using our, or we're in the domain layer, rather, we're using our domain model, which is our to-do item. And in here, all I'm going to say is repo.delete to-do item. And then pass it that to-do that we passed in. And that's all that there is for that. After the delete, we have use cases for both toggling whether it's completed and then toggling whether we want it archived or not. So same thing here, suspend fun, toggle, complete, use case. And actually, because these are use cases, I'm gonna put on the end of all of these just the word, well, you could. And typically when you do it in classes, you put the word use case on the end of all of them. But we actually don't need to do that because this is already within our to-do use cases. So we know that these are use cases. I'm going to leave use cases off the end of that. So we're going to call this toggle complete to-do item. And then again, pass in our domain model to-do item. And then inside of there, all that we need to do is say repo.update to-do item, and then this is going to be to-do.copy completed equals not to-do.completed. And that's all that we need to do. We're flipping that value on our completed field. And then after that, it's going to be something pretty, almost the exact same thing for our archive field. So we can say toggle archive to do item to do, and then pass it our domain model again to do item. Inside here, we could say repo.update to do item and to do.copy archived equals not to do.archived. And again, that's all we need there. And then down here, we can do just for fetching one single to-do item. So if I click on any one of these items from my list, it should pull up just that individual item. So if we want to pull that from our cache or even from our remote network, I need a function in here for suspend fun, and this is going to be get to do item by ID, and we're going to do it by ID because we're just getting a single item here. So we can say ID, which is going to be of type integer, and this is actually going to pass back a to-do item, which can be nullable because if we pass in an invalid ID, you're going to get a null item back. And then we say return repo dot get single item by ID and hand it that ID. Okay, so now we have all of the simple ones. And again, for really simple use cases, this is actually a very good approach, putting them all in one class, because then we don't have to have a separate class for each one of these and then put all of those in a module and tell Dagger-Hilt how to inject all of those. Rather, we could put them all in one class, and because they're so simple, it's actually quite plain what this class is doing and what each one of these functions is doing. But the only one in here that has just a little bit more logic to do it, or a little bit more logic to it, is going to be our get all to do items. So that's going to be a suspend function, get to do items, meaning the entire list of items. And then in here, we need the order. So we need to do item order of type to do item order, which is going to be equal to do item order dot time. And I'm just going to set a time in a sorting direction of down, and then a default of displaying the archived items, just because that makes sense to me. So here's our default value, time sorted down with archived showing. And then inside of here, we're going to need to get all of our to-dos from our repository. So that's pretty easy to do. We can say var to-dos equals repo dot get all to-dos from local cache. And then after that, if this doesn't return anything from our local cache, we need to pull it from the network instead. So we could say if todos dot is empty, then in here we need to say todos equals repo dot, and here we're just going to simply do get all todos. And the reason that we would pull it from our local cache first, and if we get the data that we want, not pull it from the network, is because we want to try to minimize network calls as much as we can, because one, a network call is going to slow down your code and your app. But two, for something like Firebase, where we're going to be charged for every interaction we have, well, we definitely want to keep those interactions low. And for an app like this, where it's just my app on my phone and I'm not publishing it to the store, it's not really going to matter because we're definitely not going to exceed the limits on that. But for an app that you actually publish out in the store and you have a pretty big user base, having a bug in your code where you're calling and making network calls all the time, especially if you're using Firebase, can cost you a lot of money. So that's why we're pulling from the cache before we check the network. And then after that, we're going to go ahead and check if we want to display our archived items in there. So we could say val filtered todos equals if todo item order dot show archived, then todos, else we're going to filter this. So todos dot filter, and then this filter is just going to be not it dot archived. So show all of them that aren't archived. So because this is our get to do items function, you'd be expecting that we're going to need a return type on here. So we can say list, and this would just be to do item. And we could do that and just pass back a list of to do items. But if there's an error, that could get somewhat messy for how to handle that. So one thing that we're going to do here that I like to do is down here, let's go ahead and just make a sealed class to handle our error case. So we could say sealed class to do use case result. And then inside of here, we're going to have a data class success. And this is going to have a val a to do items, which is going to be our list of to do items here. And this is going to be list to do item. And that'll just, of course, hand back a to do use case result. And then a second data class for our error. And that's going to be val message of type string. And that will hand back the same thing, to do use case result. Okay, so now that we have this to do use case result class, we're going to pass that back instead. So if I come up here, instead of passing back a list of to do items, I'm going to return a to do use case result, which, if that happens to be a success, is going to contain my list of to do items. And if that happens to be an error, it's going to contain a message that I can then use to display to the user or to debug that error later on. So within here, we need to actually return that now. So to do that, we're going to do a when statement, and basically we're going to return the result of that when statement. So return when to do item order dot sorting direction. So first thing, we're going to check which way we're sorting the data. So we can say is sorting direction dot down. And if it's down, we're going to go ahead and run that code. And let's go ahead and copy that and say is sorting direction dot up. Okay, now that we've checked the sorting direction, whether it's down or up, we need to check our to-do item order and what our index is, if that's going to be indexing on our title, our time, or our completion. So to do that, I can say when to-do item order, and then inside of here, we can say is to do item order dot title. Well, then we're going to do use case result dot success. whoops, did I spell that wrong? You want 2 S's on that. Dot success filtered to-dos dot sorted by, and then this is basically just going to be it dot lowercase, or sorry, it dot title dot lowercase. So let's take that line, go ahead and copy that, and then after this paste that 2 more times, and instead of title we want time, and then we want completed, and then here at the end we also want time, and we can get rid of the lowercase because we're it dot timestamp is what we called it. So we've got a timestamp, and then again we can get rid of the lowercase because here we're no longer comparing strings, which the title is a string, but a timestamp is obviously not, so we don't need to convert that to lowercase first. And then down here we're going to do it dot completed, which again we don't need to convert to lowercase because that's a Boolean. So that should be everything we need there. Let's go ahead and type our arrows right. Let's copy this when statement, paste it inside of our second option, and really the only thing that's going to change here is instead of sorted by, we're going to say sorted by descending. Do I have that backwards? Yes, I do. Because this is going up and this is going down. We want sorted by descending on the top, and then we just want sorted by down here. So that should be everything we need for all of our use cases. And again, this is really the only somewhat complex one. If we really wanted to, we could separate that out into a separate file and make it its own class. But because all of these are super simple, just to keep consistency within the project, I'm going to leave them all within my to-do use cases class. Now that you've made it 2 hours into this video, congratulations if you're still going with us. We've just finished building out our domain layer, so now we're going to start on the actual presentation layer. If you're just joining us, you can grab the code for this point in the video at checkpoint number 5 in the description down below. Now, in the presentation layer, we're going to need to build out our state. Also, we need to build out our view models. And then finally, we need to actually build out the UI and define the navigation that we're going to use within our app. Now that we've finished up our domain layer, let's collapse that package and then come down into our presentation layer. So in here, we're going to have 2 different packages, one for our list screen that displays everything, and then one for our new update package. So I'm going to start with the list screen. So if we come in here, we'll go new Kotlin class or file, and we're going to do a data class. And this is going to be our to-do list state. And this is basically, the state is going to be where we store all of the data that we need to handle in the UI. So inside of here, we're going to have a list of to-dos. So val to-do items, plural, and that's going to be a list of to-do items. And initially, I'm going to set this equal to, by default, just an empty list. And then after that, we need to store the order, right? Because if we look at our app here, and if you look in here, this display here is all based on the order that we have here. So basically, we need a way of remembering that within our state. And luckily, we have a class for that we created already. So this is going to be val to do item order. And that's going to be of type to do item order, which by default, I'm going to set that equal to do item order dot time. And we're going to do sorting direction dot down, and then showing archived, I'm going to set that equal to true initially. Next, let's go ahead and add 2 more variables here. We're going to have one variable to track if we're currently loading our items from our cache or from the network, because we want to be able to display a loading bar, like a circular progress indicator. So val is loading, and this is going to be a Boolean that we have equal to true. And then after that, I'm going to have an error variable. So val error, which is going to be a nullable string, which initially we're just going to have equal to null, and then we'll be able to check, and if that equals anything other than null, then we know we have an error, and we need to display that error in our app. So that's all that we're going to need for the state here. Now let's go ahead and start building out that view model. So new Kotlin class or file. This is going to be a class, and it's going to be to-do list view model. And now within this view model, we're going to have a couple different things here. First, because this is going to be using Dagger-Hilt for dependency injection, we need to annotate this with Hilt view model. And then after the class, we need to actually have this, after our constructor, we need this to be inheriting from our view model class. And now inside of our constructor, we are going to need to actually inject some dependencies. So we're going to say at inject constructor, go ahead and import that inject from our library up there. And now in here, we say private val to do use cases. So here we're basically going to have a variable up here that we can use internally. That's what private means. Internally within our view model class, and we can run all of those use case functions that we have within our use cases in the domain layer. And then after that, I'm also going to pass in a dispatcher here. So private val dispatcher, and this is going to be of type coroutine dispatcher. Now, if you remember before, when we passed in a dispatcher in our repository, we had some annotation there for Dagger-Hilt. Now, basically, the reason we did that, and I'll just come back up here and show you, in the repository implementation. So in our repository implementation, you'll remember we're providing this coroutine dispatcher and we're using the IO dispatcher. So again, in our view model, we're going to want to pass it that IO dispatcher because we're going to be launching things to use basically to get the data, which is going to be interacting with our room database and then also with our HTTP retrofit instance. So come back down into that view model that we're working on and make sure to annotate this one with @IO dispatcher as well. Now, inside the view model, we can actually start building things out. So the first thing that we're going to want to do in here is have a reference to our state, the one that we just built. So private val underscore state equals mutable state of, and then in here, we're just going to have a to-do list state. Make sure to import that. So actually, one thing you can do here, if you want to keep things simple, is you do val state equals mutable state of. But the problem with that is now other classes, they have the ability to see the state, but they also have the ability to modify the state. So like our UI can modify this state directly. We don't want it to be able to do that. We want it to just be able to view the state. So the way that we do that is we make a private variable instead. And this private variable is going to be called underscore state, which is equal to a mutable list of, or a mutable state of to-do list state. And then after that, we're going to make a public variable down here. And this is going to be state of to-do list state. And we are just going to set this equal to our private variable from the view model. So now we have this private variable up here that other classes can't see. And then we have a public variable down here that other classes can see. So what this allows us to do is we've now given our UI essentially read-only access to our private state. Now after here, we're going to add a few more variables here. And if we look back at our app that we're building here, if I were to go ahead and delete one of these, you'll see I get this to-do item deleted, and there's an undo option, and I can click undo. So to be able to undo that, we need to store that to-do item, the one that was deleted, somewhere temporarily. So we're going to have one variable up here that I'm just going to call private var undo to-do item. And this is going to be a to-do item that is initially equal to null. because we have nothing to restore and there's nothing to undo. Then next, we're going to have an error handler. So private val error handler is equal to a coroutine exception handler, and we're just going to do E for this one. Corout, make sure to spell it right. Coroutine exception handler. And then down inside of here, all I'm going to do is keep it simple, e.print stack trace. And then after that, we need to update our state. So state.value equals state.value.copy. And inside of our state, we now need to set error, which was our nullable string that initially we have equal to null. We need to set that error equal to e.message. And now, in the event that we have an error, we have a message to display to the user. And then after that, also, if we hit an error, we're going to stop trying to load. So we need to set our isLoading flag equal to false. Now, the reason that we're going to need this error handler is, of course, because we're pulling data from either a room database or potentially from our HTTP retrofit instance. And to do that, we are going to need actually a function within our view model. So our view model is going to have two main functions here. One of the functions is going to be to handle all of the events that could possibly happen from our interactions with the user, and the other is going to be to populate the data that we need inside of our UI. So let's go ahead and make that second one first. So fun get to do items, and this is just going to be our function to grab everything, and this is going to take in its do item order because we need to know what order we want to display that in. And then down here, I'm just going to say, let's see, we're actually going to need a view model. We're going to need a variable to track our job. So back up here, I'm going to add one more variable, private var get to do items job, and this is going to be a nullable job that is initially equal to null. And inside here, the first thing we need to do is take that get to do items job and cancel it. So we're going to do a save call on the cancel function there. And then once that's canceled, we can reassign it. So get to do items job. And of course, the reason that we're canceling this is to avoid memory leaks, because if we start a new job and leave the old job running, then we're going to have a problem because that job no longer has a reference in our code and it's going to continue running, and that's going to cause memory leaks and slow down our program. So we don't want to do that. So now we're going to reassign this get to do items job to view model scope dot launch, and then for this dot launch, we're actually going to pass in our dispatcher and also our error handler that we created. And then inside of here, we can actually do our call to get all of the data, all of the this to-do item list that we need to display to the user. So val, I'm going to say result equals to-do use cases dot get to-do items. And then our to-do item order is going to be equal to to-do item order, the parameter that we passed in that function. And now in here, we have two options. So we have this result, you'll remember, is not just a list of to-dos. It's actually a to-do use case result. So we can say when result, and then in here, that to-do use case result has two options. So it's either success or failure. So we could say is to-do use case result dot success. Then we're going to go ahead and run this code. Or if it is to-do use case result dot error, then we need to run everything in this code block. So basically all we need to do in here is update our state. So inside of here, we can say state.value equals state.value dot copy. And then inside of here, we say to do items is going to be equal to our result dot to do items. And then our to do item order is going to be equal to that parameter that we passed in, to do item order. And then is loading is going to be equal to false, because now that we have this list, we're not loading anymore, obviously. And then if we have an error case, we're going to do the same thing. So state.value equals state.value.copy. The difference is here, because we got an error, we're not going to have this to-do item list. So we don't need that line anymore. And then our to-do item order, we don't need that either. So instead, I'm going to put an error there. So my error is now going to be equal to, and then we need a string over here for our error. So basically, we're going to set is loading to false because we're not trying to load anymore. We tried to load and it failed. Now for the error, right now I just have a blank string. Obviously, I don't want to do that. I need to give it an actual error message, but I could put it here and say error could not retrieve to-do items. But this is bad practice. We don't want to hard code strings into our code files. So I'm going to cut that out, and we're going to come into our constants. And in here, I'm going to make a new object, and this is going to be to-do list strings. And then this is going to be for all the strings that we need within our to-do list screen. So in here, we're going to have a constant value, and it's going to be can't get to-dos. And we're going to set that equal to that string that we just made. Go ahead and go back to the view model. And now in here, we're going to use that value instead. So can't get to-dos. And that's really all that we need for this get to-do items function. And now we can go ahead and call that function to update all of the data within our UI. And the only other thing that we're going to need here is basically a function to handle any events that happen or any interactions that the user has with our interface here. So we're just going to say fun on event, and then we'll fill that out in a second. But before we do, let's just have a look at our app and remind ourselves. We can toggle one of these as completed or not. We can toggle it as archived or not. We can delete it. We can undo the delete on it. We can open it. We can sort it based on anything in here. So because of that, that's pretty much everything the user can do. Plus this actually floating action button, we can add a new one as well. So we have a set list of possible interactions that the user can perform on our app. Because we have a set list and we know what that list is, we can put all of those events basically in a sealed class. And once it's in the sealed class, we compare it nice with a when statement in our onEvent function. So to do that, come over to to-do list, new Kotlin class or file, and we're going to make an event class here, to-do list event, and this is going to be a sealed class. Enter. And then inside of this sealed class, let's just start with a data class sort, and this is going to handle any sorting events. So val to-do item order of type to-do item order, and this is going to pass back a to-do list event. And then the next one we can do is we can delete an item. So data class delete, and this is going to have a val to-do of type to-do item, or not, yeah, of type to-do item, this one. And that also is going to pass back a to-do list event. And let's just go ahead and copy that one and paste it 2 more times. And then we can delete. We can also toggle whether it's completed or not. And then we can toggle whether it's archived or not. Now there's one more thing that we can do here, and that's we can undo a delete item. So object undo delete, and that's going to be to-do list event. And that's basically all that we're going to need in this file. And the reason that all of these are taking in either a to-do item or a to-do item order as their parameter is because we need that data inside. But this undo delete, we don't need to pass any data in because back in our view model, you can actually see that this undo to-do item order is stored directly in the view model. So if that's not null, then we have the data there already. So we don't need to actually pass any data into that. So now in this onEvent function, basically we're going to need to go ahead and populate that. We need to pass an event into it, and which is going to be a to-do list event. And then we can, again, like I said, pair that with a when statement. So when event, and now in here you're going to see that goes red. And if you just hover over here and click more actions, you should be able to just add the remaining branches, and there we go. Now all we have to do is populate all of these. So let's give these all a body. And then let's go through and just start populating these. So when event is delete. So to delete, all that we need to do is do a view model scope dot launch, and then I'm going to hand this my dispatcher and also my error handler again that we created. And then inside of here, we can just say to do use cases dot delete to do item, and then hand this our event dot to do. And then after that, we've deleted it, but we need to update the list on the screen. So to update the list on the screen, we can call our get to do items, our get to do items function that we created, and we'll pass it our state dot value dot to do item order so that we get it in the same order that it's in right now. So every time we delete one, it doesn't reset the order. And then after that, when we delete a to do item, which is this event dot to do, we need to assign it to our undo to do item variable so that we can then use that if somebody clicks undo. So undo to do item is now equal to event dot to do. Now in here for the sort, let's go ahead and do that one. So really all that we need to do is say state.value equals state.value.copy. And then we're going to set that equal to, we're going to change the to do item order, set that equal to our new order. So event dot to do item order. And then down here, all that we need to do is call our get to do items. And actually, I'm just going to refactor that really quickly. So yeah, let's just go ahead and take this guy, the state value to do items order, cut that out. Because we have that within our state, we don't actually need to pass that into our get to do items function. So I'm just going to delete that out, and then down here, replace that with the value from our state and then the value from our state there as well. So now up here, this will give us an updated list. But we don't need to actually do all of that processing if our list is already, if it's already sorted the way. So if I open up my menu, right, so if I open up my menu and keep clicking sort by title, we don't want this to run every single time and update our entire list. We only want it to be updated if we change something. So if we're changing the order, then we can update that. So we need to actually, before we get down to this function, we need to check if our new order is the same. So we can do that with the basic if statement. So if, and then we'll worry about what goes in there in a second. Basically, all we need to do is return if that equals the same thing. So inside of these parameters, we need to compare our state dot value dot to do item order, and we need to compare this by the class and see if that's equal to event dot to do item order class. And we need to see if our show archived and then show sorting direction are equal as well. So if state dot value dot let's see, what is this? Show archived is equal to, whoops, I need a to do item order in there. to do item order dot show archived equals event dot to do item order dot show archived. And one more, we need to check the sorting direction as well. So if state dot value dot to do item order dot sorting direction is equal to event dot to do item order dot sorting direction. So if all of these are true, then we're just gonna go ahead and return out of this function because we don't need to get that data, it's already set. But because this is kind of hard to read, I'm gonna cut that out of the if statement and put that in a variable above this. So val state order already matches event order is equal to that thing that we just cut, and then we're going to copy that variable name, paste it in there. Okay, and now next time I come back to this function and I'm questioning what I was trying to do with this large Boolean expression, I know exactly what I'm trying to do because my variable says exactly what this is checking for. So now my sorting is done. Let's go ahead and do that toggle archived. So in the toggle archived, we're going to need to do a view model scope launch again. And we're going to use the dispatcher and our error handler. So I'm going to copy those out of there. And now within this view model, all that we need to do is say to do use cases dot and then toggle archived to do item. And then our to do is going to equal our event dot to do. And then after that, all we need to do is call that get to do items function again to update our list. And it's going to be pretty similar for the toggle completed. Let's go ahead and copy that again, paste our coroutine launcher in there. So our view model scope launch, dispatcher plus error handler. And in here again, to do use cases dot toggle, but this time we're going to toggle the completed. And then inside here, to do equals event dot to do, and then update our list with the get to do items. And finally, for the undo delete, I'm going to copy this again because we're going to need to launch that within a view model scope. So view model scope dot launch dispatcher error handler, and then inside of here, we're going to run our to do use cases. But before we show which use case, let's just have a brief look at our app again. So this is the app that we're trying to build. If I delete one of these, and then if I click the undo button, so that one that I deleted is no longer in my list. It's no longer in the state, but it is saved in the in our undo variable within our view model. So if I click undo, it takes that from our undo variable and assigns it or puts it back into our list. So to do that, we need to do actually an add. So to do use cases, add to do item, and then in here, instead of adding an event dot to do item this time, we are just going to do undo to do item, and let's just give that the Elvis operator there and say return at launch. And if we code this right, the only time you should have the option to do this undo option is when you delete one and it displays the snack bar with the undo button. So we shouldn't ever get a null item there, but just in case, we'll use it like that. And then down here, we can say undo to do item now is equal to null because we've already reassigned that one back into the list. And then we need to update our list again. So get to do items. And that should be everything that we need for the entire view model for our list screen. You've now made it to checkpoint number 6. We've just finished building our state and then our view model that we're going to use with our to-do list screen. Leave a comment down below letting us know what you think so far. And then if you're just joining us now, you can go ahead and grab the code for this point in the video from checkpoint number 6 in the description below. Okay, let's start actually building out our components for the UI. So in our to-do list, we've got this components package that we're going to populate. But before we do that, we actually have some components that are going to be shared between the to-do list and then the to-do new update button, or screen rather. So if we look on here, you can see I've got this trash can, I've got this archive button, and then I have this check circle. And if I click on one of these, I also down here have the checkbox, the archive, and then the garbage can. And basically, because these are all shared, we're going to create components in our core package that we can then use in both of these presentation packages that we have here, both the to-do list and the to-do new update. So up in core in our presentation in components, we're going to add a new Kotlin class or file, and this is going to be a file, and we're going to call this to-do item buttons. And then inside here, we're going to have a composable function. And this is going to be called our complete button. So we're going to have one function for each one of those buttons. So complete button, and the parameters here, we're going to have an onComplete click, which is just going to be a function that we can pass in. We're going to have a color. We are going to have a completed, which is just going to be a Boolean, and that's going to tell us whether this is actually completed yet or not. And then finally, we're just going to pass in a modifier. And by default, we're going to set that equal to a new modifier. Okay, now in the body of this function, basically we're going to have an icon button, and this onClick, we're simply going to set that equal to our completed click, which is the parameter that we passed in. So that's just going to be onComplete click, run that function. And then after that, we need to pass in a modifier as well. So after that, we're going to say modifier equals the modifier that we passed in the parameters above that. And then let me fix the indent on that one. And then inside of the body of this button, I'm going to have a if completed. So basically we want to put our icon, which is the checkbox, and that's going to be green if it's completed. And if it's not completed, we want to put that empty circle that we had. So if you look on our app here, you can see we have an empty circle or an empty circle, and then we have a green checkbox. So if it's completed, we're going to draw that circle, and that is just simply going to be an icon. And in that icon, there's going to be an image vector, which is equal to icons dot default dot. There should be one in here. Let's just import that so it autofills import. And this is going to be a check circle outline. And make sure to import that icon as well. And then after that, we need to have a content description. So content description is going to be equal to our, let's go ahead and back into our to-do constants file. And we're going to make a content description for that. So in here, I've got my use case strings, my to-do list strings, and then I'm going to have a content descriptions as well. So object, content, description, and inside here, we are going to do const val, and then this is going to be let's see, we'll need one for delete to-do item, complete to-do item, and then archive to-do item, because those are our buttons. So let's do delete to-do item. That's going to be equal to delete to-do item. Then we have one for const val complete to-do item, which is going to be equal to complete to-do item. And then after that, we're going to have one equal to archive. So const val archive. to do item equals archive to do item. Okay, now that we have all three of those, let's go back to our buttons, and here we're going to set that content description equal to content descriptions dot complete to do item. And then after that, we're going to add a tint, which is how you change your color on these icons. So tint equals our color that we're passing in. And then our modifier is going to be equal to a modifier dot size. And this is I'm just going to do 48 data pixels here. Okay, and then with all of that populated, this is going to be our whole complete button except this one last part. And basically, we need to draw the empty circle. Unfortunately for us, if you look in this icon's default, you won't find just an empty circle. So we're going to have to make that. But that's actually not that difficult to do. So to make that, let's just make a new function down here. And that's going to be a composable. And I'm going to call this fun empty circle. And that's going to take a color and a stroke width, which is going to be a float, which by default, I'm going to set equal to 9f. Whoops, just 9f, not 9f. And then finally inside here, we're just going to do a canvas, and we're going to need to import that one. Let's see, we want this top one with the on draw. So our modifier is just going to be equal to modifier.fillMaxSize. And then the on draw is, I'm going to set that equal to a function that's going to set our radius. So val radius is going to be equal to 39f. And then draw circle, and let's see, which one do we want here? Let's do draw circle, and then in here center equals center. Radius is going to be equal to our radius that we just defined, and then style is going to be equal to stroke width, and this width is going to be equal to our stroke width parameter that we passed in. And then, oh, we're missing one thing here. We need to specify our color on that circle as well. So color, center, radius, style. Now that we've got that, we can come up here and simply call our empty circle. So we can say empty circle and pass in our color. And then that should be everything we need for the complete button. But we've got a couple other buttons that we need to worry about, and that's that archive button and then also our delete button. So let's go ahead and do our archive button. That's going to be a composable and fun archive button. And then in here, I'm going to say on archive click is, that's just going to be a function that returns a unit. And then color of type color is going to be by default equal to material theme dot color scheme dot secondary. And then a modifier, which is going to be just the default modifier by default. And then within the body of this function, we're going to do the same exact thing where we have an icon button with an icon inside of it. So icon button, and here we can say on click is going to be equal to on click is going to be equal to on archive click. And then we're going to put a modifier on here as well. Modifier, which is just going to be equal to the modifier that we pass into that function. Just so if we want to, we can pass a modifier into this and adjust how it looks. And then inside of this button, again, we're going to have an icon. And in that icon, you have an image vector and then a content description. So our image vector here is going to be icons.default.archive, which is just that one right there, which is, you can see that matches what we had on that app that we're trying to build. And then content descriptions is going to be content descriptions dot archive to-do list item. And then also in here, I'm going to add a tint, and that tint is going to be the color that we pass into this function. And then a modifier, which is going to be equal to a modifier. Whoops, let's spell that right. Modifier dot size, and then in there, I'm just going to say 32 data pixels because I think that looks about right. Okay, and then with that, I'm just going to copy this because the next one is going to be quite similar to that. We'll go ahead and paste that down here. We just need to change the name, obviously, to delete button. And then in here, instead of on archive click, we're going to say on delete click, which means we also need to modify that down here. And then we don't need a color to pass in anymore because this is always going to be red. We'll leave the modifier there. We could say on delete click, modifier equals modifier. And then inside of here, we can do an icon, and instead of doing an archive, I'm going to do the delete icon. And then, whoops, let's import that one. Archive to do item, we don't want that one anymore. We want delete to do item, and then our color, like I said, that's just going to be red all the time, which we already have a pretty decent red for this in our color scheme. So color scheme dot error is what we're going to use. And then modifier, we're going to leave that at 32 data pixels. So now we have our delete button, we have our archive button, and then we also have our complete button. So with all of those out of the way, we can go ahead and there's one more thing actually that we're going to specify in this core presentation components package. And if you look on that app again, you'll see that these have different colors based on if it's not completed, well, if it's not archived, or if it's archived. And then also this circle here is changing colors when I do that as well. And then it changes colors if it's completed. And all of these colors that we're using here are also shared within this screen. So if I toggle that, if I archive this, all of those colors that change are shared there. So I'm going to create a composable function to give us all of those colors. So new Kotlin class or file, and this is going to be a file, and we're going to call this get to do colors. And in here, this is going to be a composable function that returns something. And the something that we want to return is going to be our color scheme. So to do that, I'm going to make a data class in here, and we're going to call that to do item colors. And then inside there, we can have a val background color, which is going to be of type color. We're going to have val text color, which again is going to be of type color. We are going to have archive color, archive icon color, which is going to be color again. These are all color. And then finally, our check color for our check icon. So basically, this class is going to give us one object where we can store all 4 of those colors for us. Now, we're going to make a composable function down here that can return that item for us. So fun get to do colors, and this is going to take in a to do object, a to do item, and then this is going to pass back the to do item colors that we just made. And I should also mention while we're here, typically a composable function, like if you look here, these all start with completed, or with capital letters rather. And that is usually the standard for when you have a composable function without a specified return type. But if I have a composable function that returns something, in this case to do item colors, we don't usually capitalize the first letter. Okay, so now within that, basically we have two options. So we could say return if to do dot archived, and that's going to determine one color scheme. And then we can say in there, I'm going to say to do item colors, and we just need to define all four of these colors. So background color equals material theme dot color scheme dot secondary dot, and this would give us our secondary color. But if you actually look at this, whoops, what just happened to that? Okay, so let's bring open that checklist app. And if you look in here, you could see that this color on the back of the card, it's blue, but I can actually see through it a little bit and I can see the background behind it, which gives it kind of a cool feel. But that means we need to make this color transparent to get that effect. So to do that, you do secondary dot copy, and basically there's a alpha value that by default is 1, and 1 means not transparent at all. 0 means totally transparent. So here, if I say alpha equals 0.6f, that's going to make it so it's 40% see-through, which is exactly what we want. So I'm going to leave that there. And then text color, I'm going to let that equal to material theme dot color scheme dot, this is going to be on secondary. And then next, we're going to say archive icon color, which is going to be equal to material theme dot color scheme dot on secondary as well. And then finally, we have that check color. So check color equals, but this one is going to change depending on if it's completed, I want green. And if it's archived, but not completed, I'm going to want white. So to do that, I can say if to do dot completed, then we're going to say material theme dot color scheme dot tertiary container is our green that we chose. And then we're going to say else material theme dot color scheme dot on secondary. So that will give us everything that we need there. Let's just go ahead and copy all of this. So I'm going to copy that part, and down here I'm going to say else, and then in my else block, let's paste that code and modify some of these values. So instead of saying secondary here for my background color, I'm going to say primary container. And then for these next two, this is, instead of being on secondary, this is now going to be on primary container. And then for my archive icon color, you might think I'm going to say on primary container as well, but I think it looks a little better with just secondary there at the time. And then finally, this last one is going to actually stay mostly the same, except we're going to change this one to secondary. So with that color done, that actually concludes all of the shared components that we're going to need up in this core package. So we can come back down to our to-do list and we can start building out the components for our to-do list screen. So the first thing that I'm going to build out is going to be our actual to-do list card. So we're going to put that in a file and we're going to call it to-do item card. And what I mean by that is if we look at this app here, each one of these is a card, right? So everything in this lazy column here, each item, buy food, this is a card, call mom, this is a card, read a book, this is a card. So we're going to build out that card item. And to do that, we're going to say at composable fun to do item card. And then this to do item card is going to basically be a composable function with some parameters here. So the first thing we need is the actual to do item, because we need all the information from that to populate the information on the card. And then we're going to have a modifier, which is going to be equal to a standard modifier. And then we need a function for on delete click, on complete click, on archive click, And then finally for just when you click on the card, because if I click on one of these cards, it should take me to the page for that item. So let's go ahead and do that. So in here we have on delete click, and this is just going to pass back a lambda function, which is of course a function that takes no parameters and returns no value. And this is what we're going to use for callbacks. So I'm going to copy that last part because we're going to use that for each one of these. Actually, I guess I'll copy it with a comma too. And then after that, we have our on complete click. And then after that, we have our on archive click. And then after that, on card click. And that should be everything we need for the constructor there. Now that we have that put together, I'm actually just gonna get rid of this phone over here. And before we do anything, I'm gonna open up split code. And then I'm gonna actually make a preview down here so that as we're building this, we can see what it is that we're building along the way. So preview, composable, and this is gonna be a fun to-do item. I'll just call this to-do item card preview. And then inside of this function, we are basically going to have a to-do theme. And then inside of the theme, we're going to call our to-do card, or our to-do item card, rather. And then in here, we can simply give that a title. We need to give that a description as well. So description, we can set that equal to maybe keep learning code, keep learning Kotlin, how about? And then we need to give it a timestamp. And we need to give it a completed value, which we'll set equal to true for now. We need to give it an archive value. I'm going to set equal to false, and then an ID can be equal to 0. And that should be all we need for the to-do item. And then we need to set all of those lambda functions, which up here we could just say on delete click is equal to an empty lambda there, and then we can say on card click also equal to just an empty function, and then we'll do that for the others as well. On archive click is going to be equal to an empty function. On complete click, same thing. So now we have a preview. We should be able to see what we're building, but obviously in Jetpack Compose, before you can actually see what you're building, you have to build your project and click refresh. So let's go ahead and do that. And now that you're back, you can see we actually have 11 errors according to this. So let's go ahead and fix those. So if you look at this error, it says here, recommended action, update the projects to use a newer compile SDK of at least 34. For example, 34. Okay, so let's do that. Basically, what happened is some of the dependency libraries that we're using require version 34 for your build SDK, but we didn't set that. So come back into your build Gradle.kts at the module app level, and let's find our compile SDK, which is 33. Let's change that to 34, sync project, and then there we go, build successful. So close out of build.gradle. Let's come back into here, click build and refresh again. And now you can see we have another error here, and it says, error, at provides methods can only be present within a module or a producer module. So this is in my dispatchers module. Let's go look in there, data dispatchers module, here it is. And basically it's complaining because I have this object where I'm putting an at provides method, but I haven't labeled this object as a module. So I need to do that. I also need to make it a singleton because I only want one of these. So let's just copy those over from my to-do module, paste those in there. By the way, it is a good idea to build your project occasionally, even if it's not going to run anything on your app that you can see, just so you can see if you have any compile errors like that. So let's go ahead and try building that one more time. And there we go. So it built successfully that time, and our preview has loaded. Of course, it's empty because we have nothing inside of our block right here, but we can go ahead and fix that. So let's go ahead and start populating that to-do function, or that to-do item card function. So the first thing we're going to want to put in here is our colors. So to import our colors, or to get our colors rather, we can use that function that we just wrote. So I could say val to do colors equals get to do colors, and to do is going to equal this parameter to do that we passed in. And then let's go ahead and make a card, and I'm going to go ahead and use the second one with the on click, and then make sure to opt in for this experimental material 3 API. And then on click, let's see, inside of this card, we need to define some parameters. So a modifier is going to be equal to a modifier. And because I want this to go across the entire page, or the entire screen rather, I'm going to say fill max width. And then we're going to give this a shape to make it look a little bit more like it does in our app here. And we can say shape equals rounded corner shape, size of 24 data pixels. And then this on click, instead of writing a function there, I'm just going to set that equal to our on card click function that we're already passing in. And then our colors can be equal to card defaults dot card colors. And then basically we need to do container color equals to do colors dot background color. Now within this card, we need to have a, let's see, we're going to have a row. Import that row, composable row, and then inside of this row, I'm going to give this also a modifier. Modifier is going to be equal to our modifier that we passed in as a parameter dot fill max width, because we want this to go across the whole way as well. And then I can say horizontal arrangement equals arrangement dot start. So this one here, arrangement dot start. And then finally, within this row, we're going to put the complete button. And then we're going to hand that the on complete click to do colors dot check color, and then to do dot completed. Okay, so we have that. Let's go ahead and create that. What did I spell differently? Create composable. No, there should be an option for importing that. Let's see. Let's just make sure we spelled that the same in our to-do item buttons. And we spelled that complete buttons. Let's get rid of the S and just have that be single. So now if we come back down into here, complete button should be something we can just simply import. And now that we have that, let's add the text beneath that. And this text is going to be, let's see, text is going to be equal. And you could see over here, it's actually starting to populate our preview and show us what our card is going to actually look like here. So let's go ahead and import text. And then text is going to be equal to to-do.title. And then style is going to be equal to material theme dot typography dot headline medium. And then font weight, I'm going to use bold because this is a title, and the color is going to be equal to do colors dot text color. And then font size, I'm going to set equal to 32 just because I think that looks pretty good, 32 SP. And then max lines, we need that equal to 1. And basically, if my title is too long, that way it won't wrap onto the next line. So like if I come down here at my preview and make this a little longer, subscribe to my channel and like this video, So now this is going to be too long for this, so it's going to actually not wrap onto the second line. Instead, we're going to say overflow is equal to text overflow ellipsis. And as soon as that populates over there, you'll see that. We have to import that bold. So now we have our complete button and then a text, and that's in one row. But then beneath this row, I need to go ahead and add another row. And then inside this row, let's just give that some vertical alignment. So vertical alignment equals alignment.top. And then inside this row, we're going to have a column. And for the parameters for that column, let's go ahead and say modifier equals our parameter modifier dot fill max width dot, and let's give that some padding. Maybe start, we'll set that equal to 8 dp just to space that out just a little bit there. Then give that some weight as well. I'm just going to do 1f. And finally, vertical arrangement. Oh, you need a comma there to make it autofill. Vertical arrangement is going to be equal to arrangement top. And then inside this column, we need to actually put the text for the description of our to-do item. So I could say text. And then inside here, we can say text equals to-do dot description. Style is going to be equal to material theme dot typography dot, we'll say body large for this one. Color is going to be equal to do colors dot text color, and then font size is going to be equal to 24 SP, and max lines on this one, because this is the body and the description, it can go more than one line, but we don't want it to be so many lines that we can't see anything anymore. So I'm going to set max lines equal to 10, just so we always have multiple items that we can see when we're scrolling through this on our screen. And then the same thing here, we're going to say overflow equals text overflow ellipsis. Now after this column that we have here, this column, we need to go ahead and do another column for our buttons. And just so you can see how this looks, let's make this actually a little bit longer. Keep learning Kotlin so that and learn how to make really cool apps. Okay, so now that's a little bit longer. It should go on to the second line and just give this a little more, a bigger look to it. And then while that's rendering, you can see that here. Let's go ahead and make a second column here. So column, and then let's hand this a few parameters. Inside of here, I'm going to say vertical arrangement equals arrangement.center. And then horizontal alignment is going to be equal to alignment.center horizontally. And then where you need a modifier there, which is going to be equal to a new modifier, and then dot fill max width dot weight, and I'm going to weight this at 0.1f because that'll make it about the right size, and then padding end is equal to 4.dp. Now there we go, you have this. Now within this column, I'm going to go ahead and say archive button, and then this archive button, we're going to pass in a on archive click, and then we're going to pass in to do colors dot, and this is just simply going to be our archive icon color. And then after we have the archive icon, I want to add one more icon here, and that's going to be our delete icon, or delete button rather. So our delete button, which is going to be our on delete click, and we'll have to import that one as well. And now, as soon as this render is complete, you should see the full version of our to-do card that we're going to be using inside of this app. So there it is. You can see we have our card, you have our checkbox, and then you have the title, the text inside of the title, the description rather, and then you have both icons, one for your archive and then one for your delete. So that's done. Let's go ahead and start building out our sorting menu now. So to do that, let's look at our phone really quick. And let's look at, this is the app that we're trying to build. So we built this card so far. Now, if you click on here, you can see we've got each one of these rows, and it looks like I have a text and then just an icon over here that's either visible or not visible, which is simply a check mark. So to do that, I'm going to build a row as a function, and then after I build that row, I'm going to build this whole entire menu as a function. So let's get started in doing that. In our components, let's go ahead and do new Kotlin class or file. This is going to be a file. I'm going to name that one sorting row. And then in here, basically, I'm going to have a composable function. And this is going to be, I'm going to call it icon row. So icon row, because essentially it's a row with a text and an icon. Our modifier, whoops, not that one. Modifier with that is going to be just a standard modifier by default. And then text is going to be a string. And then is checked is going to be a Boolean. And that is really all that we'll need for our parameters up there. So now within this, all I'm going to need is a row that has a text and then an icon. So let's do that. We have a row. Then inside of the parameters for that row, I'm going to say horizontal arrangement is equal to arrangement dot space between. We're going to say vertical alignment is equal to alignment dot center vertically. And then I'm going to have another modifier in here, which is going to be equal to that modifier parameter that we passed in. And we're going to let that one be fill max width. And then inside of this row scope, let's add a little bit more. We need that text, first of all. And then inside of that text, I could say text is equal to text, which is the text that we're passing in up here. Text is equal to text. Font size is going to be equal to maybe 24 SP, should be about right. And then line height is going to be equal to just a little bit more than the font size. So we'll say 30 SP. And then after the text, all we need is an icon. But we don't always want to display the icon. Really, we only want to display the icon if this is checked variable is true. So we're going to do if is checked, then icon. And inside of this, whoops, let's import that. Not that. Import. We want this, let's see, this top composable one. And then we're going to say image vector equals icons dot default dot check. And then after that, we can say content description is going to be equal to, let's see, we have our content description. Let's see, content descriptions dot. But so far, I only have a delete, an archive, and a complete. So I actually need to go back over into my content descriptions and add a few more in there. So let's come up to our to-do constants file. And in here, the content descriptions, we're going to want to add just a couple more for our sorting list. So let's go ahead and do that. Const val selected is going to be equal to selected. And now that we have that, we can come back to our sorting row and we can say content descriptions equals content descriptions dot selected. And then after that, we are, let's see, we need one more thing, and that's just we need to set the color of this row. So, or the color of this icon rather, and I'm going to say tint equals material theme dot color scheme dot on secondary container. Now that we have the row, let's go ahead and build out the drawer that that row is going to be a part of. So in components, right click new Kotlin class or file, and this I'm going to call sorting drawer options. That's going to be a file. And then in here, this is going to be a composable function. Fun sorting drawer options. Now for parameters, for this, I am going to pass in basically my to-do item order. So to-do item order, this third one here, and that's going to tell us where to put the checkboxes on that. And then we're going to pass in an on order changed function. So on order change, which we're going to set equal to do item order, and then we're going to hand back a unit there. So we're going to take in the order, and then we're going to pass back a unit. So now within here, for each row that we have here, I'm going to need to compare this title row and then the time row and then the completed row against the item order that's stored in this to-do item order that they're passing in here. So let's start off with the title. I could say val title selected, which is going to be a Boolean. It's going to be equal to to-do item order class. If that equals to-do item order dot title class. Okay, now with that Boolean, we can go ahead and build out a navigation drawer item. So navigation drawer item, and let's just space these out a little bit. So my on click is going to be equal to, let's see, on click is going to be equal to on order change to do item order dot title, and then inside there we're going to say to do item order dot sorting direction, and then after that to do item order dot show archived. My selected is simply going to be equal to, let's see, we'll set that equal to false, and then in here for my label, this is going to be my icon row, and my icon row is going to have inside of it text equals to do list strings dot, and we're actually going to need some text here. So basically, you've got all of this text within this navigational drawer, or within this drawer here. You've got sort by, title, time, completed, sort up, sort down, archived, and we've been putting all of our text into this, not that one, into our to-do constants file in here. So this to-do list strings, let's go ahead and add all of the constants that we're going to need for our sorting list. And the first one, actually, we just need this at the top of the main page of the app, is going to be const val to-do list is going to be equal to do list, which is the text we have displayed at the top of the page. Then we have const val title is equal to title, const val time is equal to time, const val completed is equal to completed, const val, let's see, sort up and sort down. Sort up is going to be equal to sort up, and then const val sort down is going to be equal to sort down. And then after that, we've got the archived. So const val show archived is going to be equal to show archived. And then finally at the way top of that menu, we're going to say const val sort by is equal to sort by. And let's just double check in on our app, see if there's any text here that we have on our menu, but not in our constants. And it looks like we got it all. So with all of that done, we can come back to our sorting drawer options now. And this one here, to-do list strings, now if I hit dot, I've got a whole bunch of them, and this is going to be equal to title now. So our text is going to be our title, and then after that we can say is checked is going to be equal to our title selected. Okay, now with all of that, we better opt in for this experimental material 3 API. With all of that, really all we're going to need to do now is copy this and paste it a few more times. So let's copy this entire block of code, paste it down here, and now instead of title selected, this is going to be time selected. This needs to actually be time class now, and down here we need to say time, also time selected, time all uppercase, time selected, false, and then on order change, instead of title, we say time now. And that should be all that we need there. Let's paste that one more time. And again, instead of title selected, now we can say completed selected. And then we can say to do item order equals class, to do item order equals completed. Down here, instead of title, we can say completed. And then we could say is checked is equal to, instead of title dot selected, we want completed selected. And then finally down here on order change, this title needs to change to completed, and that should be good for that one. After those three, if you look in the app, I've got a line there. So I'm going to stick a divider and then put the next two. So to do that, all you do is type divider and then import that. After that divider, let's paste that code one more time. And here, instead of title selected, we're going to have sort down selected. And sort down selected, instead of comparing classes here, now we're actually going to compare that sorting direction within the class. So sorting direction equal to sorting direction dot down. And then down here, inside of here, instead of title, sort down, instead of title selected, we can say sort down selected. And then in this on order change, instead of title, we're going to delete all of that and say copy sorting direction. This actually, we want to change that too. This is going to be our parameter that we passed in, not the class. So to do item order dot copy sorting direction dot down, and then to do item order dot show archived. And that should give us our down. We can copy that now and paste it again for our up. And this is going to be sort up selected. And then this we want to equal to sort up. Now icon row, instead of sort down, we're going to say sort up. And is, let's see, is sort up selected. And then on change to do item order copy, this down, we want to change that to up. So that's the last of the sorting menu. We don't need anything else there. So we can close out our components and we can actually make that to-do list screen now. So new Kotlin classroom file, to-do list screen. And then inside of this file, let's just go ahead and open up our running device and just have this open so we can see what that's going to look like. And over here, we can say at composable, and then this is going to be fun to-do list screen. And inside of this screen, we're going to need a nav controller coming in. And then after the nav controller, we're going to need a view model coming in. And that's going to be our to-do list view model, obviously, which is going to be equal to a Hilt view model by default. And I should also mention here, I know passing the view model in can actually be a little bit of a controversial question, because sometimes people will say, well, you don't want to pass the view model into your screen because that limits your reuse capabilities, because now you have this screen always paired with this specific view model. But because of just the sheer number of events that we're going to be using inside of this view model, it's just a lot easier in this case, and I'm not planning on reusing this screen in any other project. So for us, this is not going to be a problem. It will make testing a little bit more difficult, because your screen is now essentially tied to your view model, which means you can't test your screen UI without an instance of your view model. So there's definitely a trade-off there, but this is going to be a lot easier than the alternative, which would be passing in every single function that we need and as a parameter up here, and we don't want to do that. This will be easier in our case. So in here, we're going to get the state first of all. So our state is just going to be val state equals view model dot state dot value. And then we actually need a snack bar host state, because we're going to be hosting a snack bar inside of here at times. For example, if I delete an item here, you can see I get this snack bar that pops up. So let's add that. Val snack bar host state is going to be equal to remember snack bar host. And this, nope, that's not right. We want remember snack bar host state. We need to import both of those. Okay, now that we have those two, we need a drawer state, and that's going to be for this drawer over here, which is our sorting menu. So val drawer state is going to be equal to remember drawer state with an initial value equal to drawer value dot closed, because we want that closed when we open it up. Make sure to opt in for the experimental stuff there. And then here we have drawer value dot closed. Why is that not happy? Initial value equals drawer value dot closed. That one right there. Okay. And then down here we do val scope, and this is going to be equal to our remember coroutine scope. And after that, let's see, we are going to need, okay, so basically, if I were to take this screen here and rotate it, you can see that things are going to be laid out a little bit differently, and my background has actually changed a little bit. So the reason for the background changing is because I actually have two separate backgrounds, one for if it's portrait and one for if it's landscape. So I'm going to just grab those from my computer here and paste those backgrounds in. And they go down here, res, drawable, paste those two in. Oh, system clipboard is unavailable. That's not good. Okay, paste those in, and now you can see here's our landscape background, and then here's our portrait background. So because we have two different backgrounds, we're going to need to actually know the orientation of this phone. We're going to need to know the orientation of this phone if we're planning on changing the background based on that. So to do that, I need variables up here to track that orientation. So I'm going to say val configuration is going to be equal to a local configuration dot current, and then after that, val is portrait is going to be equal to configuration dot orientation equals android.content.res.configuration dot orientation portrait. So that's going to give us a Boolean variable to tell us if we're in portrait or landscape mode. And then here we can simply just set val background. So val background image is going to be equal to if is portrait. Then it's going to be r dot drawable dot background. Let's go ahead and import that. Let's see, background portrait, else r dot drawable dot background landscape. So now we have the background image based on whether this is going to be a portrait or a landscape orientation. So beneath that, we're almost ready to start building this composable down here. But before we do that, we need to add a launched effect. So this is going to be launched effect key1 is equal to true, and I'm just going to delete the block. I don't want that there. And inside here, all I'm going to say is viewModel.getToDoItems. And the reason that I'm doing this inside of a launched effect instead of inside of a, say, an init block, which you could do, and that would load everything initially. But if I do it inside an init block instead of a launched effect, and then I click on one of these, and if I were to make a change, and then hit save, and when it comes back, you can see that change shows up here. But if I did this in a init, that change wouldn't show up. I would need an additional refresh function to get that change in here. So that's why I'm doing this get to do items here in launched effect. And okay, now that we have that, now we can finally start building our actual composable, the bulk of our composables down here. So we're going to start with a modal navigational drawer. And then inside here, I'm going to say drawer state is going to be equal to my drawer state variable from above. And then drawer content, let's delete that to do out of there. And then in here is where we want to put our content. So this drawer that we're building here, at least this part of it, is going to be this sorting menu here. So to get that, in here, we're going to say modal drawer sheet, and then inside this sheet, we're going to have a text, and this text is going to have text equals to do list strings dot sort by, and let me just import that text here. So sort by, and then modifier equals modifier dot padding, and I'll just set that equal to 16 data pixels for now. Make sure to import that modifier. Okay, with that, we can say font size is going to be equal to 34.sp, and then line height, we want that to be just a little bit bigger than our font size, so I'm going to say 38.sp for that. And then after that, you can see in here we have sort by and then a line, so I'm going to put my divider line there. And then after my divider line, I could say sorting drawer options, which is going to be that function that we already built for all of these options down here. And in there, let's space that out just a little bit. I'm going to say on item order is going to be equal to state dot to do item order, and then on order change is going to be equal to this function here, and we're going to say order. And then with that order down here, I'm going to say view model dot on event, and then to do list event dot sort, and then pass it that order. Now we need to go ahead and put a scaffold down here. And a scaffold, of course, is kind of like a box, except with the added benefit that along with the scaffold, you get the option to pass in a floating action button, a top bar, and then a bottom bar as the parameters. So to do that, inside of this scaffold, I'm going to say floating action button equals, and then this is going to be equal to, in here, we're going to say floating action button, and then we need to define an on click for this one, which I'm just going to leave as to do for now, because that's actually going to be pretty dependent on our nav controller, because we can't, if I were to come in here and click this floating action button, you can see it takes me to another page, and we haven't built that page yet. So I'm going to leave the on click as kind of just a to-do item for now, no pun intended, because we're building a to-do app. And then in here, after the, let's see, we could say shape is going to be equal to circle shape, and then container color is going to be equal to material theme dot color scheme dot primary. Import that guy. Okay, and then inside of this floating action button, I'm going to have an icon, and that icon is just going to be an image vector equal to icons dot default dot add, and we're going to say content description is going to be equal to content descriptions dot, and I might need to go add, yeah, I'm going to need to go add add one to that. So let's import that icon, import that add, and now let's go find our constants file. So inside of to do constants, I'm going to need content descriptions const val add equals add. Actually, we'll call this add floating action button. So now I can copy that, come back to do list screen and say to dot add. And then actually, let's call that add to do. So now in content descriptions, instead of add floating action button, we'll just call that add to do item. That will make a little more sense. The user doesn't care that that's a floating action button. Okay, and then after that, let's give that a color. We can say tint is going to be equal to material theme dot color scheme dot on primary. Because this is going to be a primary color, we want the on primary for that. And then after this floating action button, let's go ahead and add our top app bar. So for that one, I'm going to say top bar is equal to, and then, oh, just one equal sign. And then inside of here, let's go ahead and add our top bar. So center aligned top app bar. And our title, let's go ahead and add that, delete that, enter. Okay, so our title is going to be, let's see, let me get the spacing all right here. It's going to be a text, and inside of that, we're going to have text equals to do list strings dot to do list. Space that out just a little bit because we're going to have a few more parameters to pass in there. So max lines, because this is a title, we're going to set that equal to 1. We're going to say overflow is going to be equal to, I guess we probably don't need to specify an overflow because we've already preset that title and it can't change. But whatever, we will. Style equals material theme dot typography dot headline. Headline large is fine. And then one more thing down here, I'll do color is going to be equal to material theme dot color scheme dot on primary. Okay, so now that we have all of that, that's just our title. We also want to customize the colors for that top bar. So to do that, after my title, I'm going to add one more parameter, and we're going to call that colors is going to be equal to, and this is going to be a top app bar colors dot center, oh sorry, not colors actually, top app bar defaults dot center aligned top app bar colors. And then inside of here, we can say container color is equal to material theme dot color scheme dot primary dot copy. And then again here, you can see this is semi-transparent. I can see through that. So I'm going to add an alpha to that. So that's why we're doing the dot copy, because then we can specify an alpha on top of our theme color. And I'm going to say that's going to be 0.7f. And then we can say scrolled container color equals material theme dot color scheme dot primary. And then I can say navigation icon content color is going to be equal to material theme dot color scheme dot on primary. And then we can say title content color is going to be equal to material theme dot color scheme dot on primary. And then after that, we can say action icon content color is going to be equal to material theme dot color scheme dot color scheme dot on primary again. And then after this colors, we need to add one more parameter in here. And well, actually two more. So we need our navigation icons, but I don't really want any. That would be like here we have the back arrow, but on this screen we don't have any. We're going to navigate by clicking on the cards themselves or by clicking on the floating action button. So I'm going to leave that one empty. And then actions is going to be equal to, and then in here we're going to say icon button. And then for this icon button, our on click is going to need to launch our sorting menu. So in here, we can say on click equals scope dot launch, and then we're going to launch our drawer state dot open. And that will give us our sorting menu with that. And then after that, inside here, we have this icon button. I want to actually put an icon on that button now. So I'm going to say icon, and our image vector is going to be equal to icons dot filled dot menu. And then our content description, it needs to be equal to our sorting menu. Content descriptions dot, and I don't have a sorting menu. So let's go back over to our to-do constants. And in our content descriptions, I'm going to add one for that. So const val sorting menu is going to be equal to sorting menu. Okay, copy that, come back to to-do list constants, or to-do list screen rather, and let me just space that out so it looks a little bit better. Okay, so now we've got that top app bar with the title in the middle and then our icon for opening up our sorting menu. Now we need to define, let's see, what else do we need to define? After actions in here, I need to put a scroll behavior because some of them, if you scroll like this, it'll disappear, and then if I pull it back, it'll come back. So there's different scrolling behaviors for these top app bars. So here I can say top app bar defaults dot, and this one I just want always to be there. So I'm going to say pinned scroll behavior, and this is going to be equal to remember top app bar state. Okay, so that will keep, this line right here will keep our app bar pinned to the top even if we're scrolling down. And then after that, there's one more parameter down here that I'm going to need for my scaffold, and it's my snack bar host state. So my snack bar host is going to be equal to snack bar host, whoops, not that one, snack bar host, let's see, get rid of those brackets, and we're going to say host state equal snack bar host state, which is that variable that we made earlier. And now we're totally done with our with our scaffold. So at least, well, I shouldn't say we're totally done with the scaffold. We're totally done with the constructor for the scaffold. Because in here you can see we have a floating action button and a top action bar, but I don't have a bottom app bar. So we're not going to worry about that in here. And then finally, within the content of our scaffold, we can go ahead and define what we want this to look like. And you get a padding value here. So I'm just going to pass that in, but we're not going to use it. I'm going to go ahead and suppress unused material 3 scaffold padding parameter because we're going to specify our own paddings inside of that. Let me actually get rid of that, and we're going to suppress that up top. So all the way at the top of this file, I'm going to say, let's see, this is what we want, suppress lint unused material 3 scaffold padding parameter. And then we also are going to need, because this is material 3 and some of this is still in experimental, we are going to want to do experimental material 3 API and then opt into that down there, and we should be good to go with no errors down below now. So inside of this scaffold, we can go ahead and start defining what we want. And the first thing I'm going to do is I'm going to make a box in here. And for the parameters of this box, we're going to say content alignment equals alignment dot top start. Whoops. Alignment dot top start. And then in here, modifier equals a modifier dot fill max size. And then we need a background color, so dot background color, and then color is going to be equal to material theme dot color scheme dot background. Content alignment. Why can't we find that? We have a box, and then we have content alignment. Did I spell something wrong here? There we go. Okay, so inside of this box, we are going to need an image, and basically this is going to be our background image. So let's go ahead and import our image here, and we want, let's see, we want this top one here. Image painter is going to be equal to a painter resource, and my ID is going to be equal to a background image, which is my variable from above that you remember we defined based on if this is portrait or landscape. And then we're going to do a content description in here. And for that, we need to come back up to our constants file. And then in here, we're going to make a new one, const value background image is equal to background image. So now come back into here, and we can say content descriptions dot background image, and then I can say content scale is going to be equal to content scale. We want to fill the width, and then after that we want modifier is equal to modifier dot fill max size. And then lastly, we're going to want to align this at the top so that it's always locked in place. So our width is always going to match the width of the phone. And then we're always going to align it at the top so that if there's some extra, it'll just fall off the bottom and we won't need to worry about it. So alignment dot top start. And then after this image, or rather on top of this image, we're going to put a column. And we'll come back to that column in a little bit. But for now, let's just leave a modifier in here. And we'll say modifier equals a new modifier dot fill max size. And we'll come back to what goes in there, and which is going to basically be our lazy column that holds everything. But before that, down here, what I always like to add is if something goes wrong or if loading is taking longer than normal, we want the user to be able to know that. So we're going to say if state.isLoading, then in here we're going to have a column And inside of this column, I'm going to say circular, what did I spell wrong there? Circular progress indicator. And then inside of here, you technically don't have to put anything here, but I'm going to put modifier dot semantics. And then inside of the semantics, we're going to say this dot content description is equal to, and I guess we should import all of this stuff. In here, we're going to say content descriptions dot, and this needs to be a loading indicator, which I don't have. So come back to my constants file. And in here, we're going to say const val loading indicator, and we're going to set that equal to, I'll just call this loading. And now if I come back here, I can name that, and you technically don't need this for a circular progress indicator, but later when it comes to unit testing and you have no text in here, so you have nothing to test that by, having this content description in the modifier semantics is going to give you the ability to test whether this is visible or not. So even though you don't need it, it's a good practice to put it there. This, however, is going to put it up in the top left corner because we didn't specify where to put it. So we need to put some of that in this column. So we're going to say modifier equals, and then we'll say just a new modifier dot fill max size. And then after that, we'll say vertical arrangement equals arrangement dot center to put that in the middle. And then finally, horizontal alignment equals alignment dot center horizontally, and that's going to put that right in the middle of our screen when that's loading. So now I am actually let's just copy this whole if statement here and paste it right below. And what we need to do is check the error. So if we have state dot error not equal to null, then we know something's wrong. So I'm going to leave all of this the same because I want it right in the middle of that. And then this I'm going to delete. We don't need that anymore. What we need in here rather is a text, and the text is going to be state.error. And let me just give that a few more parameters to make it look a little bit better. We're going to say font size is equal to 30.sp, and then line height is equal to 36.sp. Okay, so that's going to display an error if we have one, and this is going to display our loading screen when it needs to. So now we just need to know what to put in this column, which is going to be the bulk of our program, which is what we see here when we actually run this. So we have essentially a lazy column with a bunch of those to-do item cards. So let's go ahead and fill that out. So first of all, we have this filling the whole screen, and then inside of this, we're going to say lazy column, and inside of this lazy column, we'll pass in a few parameters, actually just a modifier. So modifier is equal to modifier dot, well, we'll do on the next line dot fill max size, and then dot padding. I'm going to give it horizontal padding, and that's going to be 12 data pixels. And then I'm also going to give it padding just from the top. So at the way top here, when you're all the way up here, we don't want this top card to be flush against the menu. We want a little gap in between. So that's what this padding here is for. And I'm just going to say top equals 64.dp. And actually, I'm adding a little bit to that because we're in a box here, and the box is going to put things all the way up against the top of the screen, and we have an app bar up there in the way. So a top app bar is going to be 64 data pixels in height according to the Material 3 webpage. So I'm just going to add 64 data pixels of padding right there to offset that. And now inside of our lazy column is where we actually get to populate our app. Okay, and now within here, items, and then this is going to be state.todo items. And then the this it that's coming in, we're actually going to change that to a to-do. Pass in a to-do. Go ahead and import this. And then in here, we are, for each of these items, we're going to create a to-do item card. And the to-do is going to be equal to to-do, this guy coming in right here. Oh, whoops, not the comment to-do, our incoming to-do from the Lambda. And then down here, our on delete click, this is just going to be view model dot, and then we're going to say on event, and then this is going to be a to-do list event dot delete to do. And let's fix that spacing there. And then after we do that, we actually need to launch our snack bar, because again, if we delete one of those, you see we get this snack bar option popping up so that we can undo it. So after we actually run our delete, we need to do scope.launch. And then inside of this launch, we're going to do val undo equals snack bar host state dot show snack bar. And then in here, we have our message, which is going to be equal to a string, and then our action label, which is also going to be equal to a string. And again, you'll remember I've been putting all of our strings in our constants file. So come back to to-do constants, and up in our to-do list strings, we're going to put const val to-do item deleted. And then this is just simply going to say to-do item has been deleted. And then after that, I'll add one more const val, and this is going to be to-do list strings dot undo. And this is going to, actually, what am I doing? We don't need that whole thing. This is going to be undo equals to whatever text we want to show on the undo link, which is just going to be undo. So now that we have those two, and also this is a little suspicious that our show archived is showing up gray. So let's just double check our components in here. Let's double check our sorting drawer option. And we have sorting direction up, sorting direction down, but it looks like we actually forgot one of those. So if you look in here, we have up, down, and then finally we have archived. So we're going to actually need to go ahead and add that. Make sure that we get everything here. So you've got another divider and then archived. So after here, we're going to add another divider. And after that, we're just going to copy, well, I don't know about that. Here, I'll just type it out down here. So after this divider, we have our navigation drawer item and our label here. Okay, so our label is going to be equal to icon row, and then inside of the icon row, the text is going to be to-do list strings dot show archived, that one that was gray, which tipped us off to the fact that we forgot this. And then this is going to be to-do item order dot show archived. And then down here, selected, we're going to set that equal to false. And then on click, I'm going to set that equal to basically on order change, and then to do item order dot copy, and then we're going to do to do item order dot sorting direction, and then we're going to do not to do item order dot show archived. Whoops, and this actually is not the class, this is the variable, so little t. Okay, and that should implement that custom copy function that we put in place, and now we should be good to go with that. So come back to our to-do list screen now, what we were doing, and we're going to say to-do list strings message equal to-do item deleted, and then action label. that's going to be, the action label is whatever is highlighted in blue down here, which is going to be our undo button. So action label equals to do list strings dot undo. Okay, and then once you have that, we have to actually define what happens whenever the user is going to click that undo button. So after that, we're going to add an if statement down here, and it's going to say if undo equals, or if undo is equal to snack bar result dot action performed. Then we're going to go ahead and run this code, which is simply going to be view model dot on event, and this is going to be a to-do list event. And in here, it's going to be a to-do list event undo delete, which will then add that item back into the list if we go ahead and click that. So there we go. That's all we need for the on delete click. Kind of complicated, but there you have it. So in the on complete click, it's a little bit simpler than that. We just say view model dot on event, and then this is going to be a to-do list event again dot toggle completed, and then end it our to-do. So that is going to be almost identical to our on archive click button here. So let's go ahead and add that. So on archive button click is going to be view model on event to do list item toggle. Instead of toggling completed, we're going to toggle archived. Okay, there we go. There should actually be one more parameter. Let's see, for our to-do item card, what did we do? To-do item card, at the top of this file, we have on archive, on card click. So we need to define that parameter as well. So come back into our to-do list screen. After on archive, we're going to say on card click. And right now, so in this app, when I click on this, it's going to navigate to the next page. And again, we don't have the next page. So what we're going to need to do is nav controller dot navigate, and then in here, we need to define all of that activity. But before we do that, there's a couple things that we need to do. One, we need to define the routes for our pages. So for the first page and then for the second page. And two, we actually need to set up that nav controller in our main activity. So I'm going to put that on hold for now, and we'll come back to that. And oh, and I guess this on card click, that was actually this lambda function that it gave us down here. But I'm going to put it up in the parameters just because I think that's a little bit easier to read. So we'll leave that as a to-do item, and we'll come back to that when we have the next page. And now this should actually be just about done. At least this page. We need to go on over to our main activity here. And actually, before we do that, we need to actually make an app for this program. We need to make the app so that we have the context. So to do that, come all the way up in our to-do package. And so at the top level, above all of our features, we're going to make a new app up here, or a new file up here, Kotlin class or file. And this one is going to be a, oh, sorry, I lost that. New Kotlin class or file. This is going to be a class, and I'm just going to call this our to-do app. And there we go. This is pretty simple. It's going to be a class that inherits from application. And then we don't even need the body on this at all, but we do need to annotate this with @hilt Android app. Next, we need to actually add this name to our manifest file. So come up into your Android manifest. Up here under the top application level, we're going to say Android name, and this is just going to be equal to .todo. And now that we have that, we should be good to go with this file. We can go back on into our feature to do presentation and open up main activity because we have left that empty up until now, and we definitely need to fix that. So inside of here, I'm going to get rid of this color because we're dealing with the cover instead of our screen. Instead, we need a nav controller, and then we need a view model that we're going to pass into our screen, our composable. So to do that, I can say val nav controller of type nav controller is going to be equal to, remember, nav controller. And I guess technically we don't even need this part here. I can just say nav controller equals, remember, nav controller, and then val list view model is going to be of type to do view model, sorry, to do list view model is what we named that. And then this is going to be equal to a hilt view model. And then after we have that all set up, we need to set up our routes down beneath that. There's actually another file I'm going to make. So in our util package inside presentation, we're going to do a sealed class. And this is basically going to be for storing all of our routes, because we know that we know all the routes that our application is going to need to take. Therefore, this is a finite set, so it's pretty easy to represent with a sealed class. So I'm just going to call this screen. And then inside of here, we're going to say val route string. And then we're going to have two objects in here, one for each of our screens. So this is going to be a to-do item list screen. And this is going to be screen. And the string is going to be, or the route rather, is going to be to-do item list screen. And then after that, I'll go ahead and just add the other one right now, even though we haven't done it yet. We're going to say, instead of to-do item list, we're going to say to-do new update screen. And then this is going to be, again, instead of to-do new item list, to-do new update. And now we have both of the routes set up, so we're ready for both screens here. And we can come back into main activity, and down here, after our variables are set up, let's go ahead and make our nav host. And let's see, let's space that out a little bit. Our nav controller is obviously going to be equal to our nav controller that we created above. And then our graph, I'm actually going to delete that parameter. I don't want that in there. I'm going to say our start destination is going to be equal to screen dot to do item list screen dot route. And we'll have to import all of this stuff. So import, we want to import this one, the one that I created, not this Android X Compose one. So we're going to do that. And then find no function for start destination. There we go. Okay, so yeah, so the reason is because before I had the graph up here, right? But if I take that graph out, and now I have this nav graph builder. So we're actually going to build the graph inside this Lambda function here. And I'm going to say composable route is equal to screen dot to do item list screen dot route. Well, then inside of here, we are going to say to do list screen. And then in here, we have two parameters. So our nav controller is going to be equal to our nav controller. And then our view model is going to be equal to our list view model that we just created above. And then go ahead and import that. So that is going to be, we'll opt in for that experimental API again. And then this is our first composable. And then down here, we'll go ahead and set it up for the next one, even though obviously this doesn't exist yet. So composable, we'll say our route is going to be equal to screen dot, and this is going to be the new update screen dot route. Okay, let me fix that spacing. Always I'm fixing spacing. Okay, in here, we have our route, and then we will worry about what actually goes in there later. So we'll mark that with to do. Now we should One more thing we need to do here, we need to tell our compiler where the entry point for our application is. So we need to mark this with @Android entry point. And then let's go ahead and run this on the phone and see what happens. So I've got this AVD here running my old app that we're trying to build. And now I'm going to switch to a new one and click run on this. Okay, so we actually got an error here, but it should be pretty easy to fix. You can see it says to-do list repo cannot be provided without an app provides annotation or annotated method. Basically, if we come on over, let's look in our to-do module up in our data, and you can see here we've got provides retrofit API, provides retrofit, provides room DAO, and provides room database, but we don't have anything up here for providing our repository, which is a problem, of course, because we're using that dependency all over the place. So let's go ahead and add that. So at provides, and this is again going to be a singleton, and this pretty much needs to be fun, provides, this is going to be our to-do repo, and we're going to take in a DB of type to-do database, and then an API of type to-do API, and then we are going to do this IO dispatcher of type dispatcher, IO dispatcher, and this is not actually going to be an IO dispatcher, so dispatcher coroutine dispatcher. And basically, we here are going to return a to-do list repository. And we want to, of course, return the repository, whoops, with an O, not the implementation. So down here, we're going to say to-do list repo implementation, which is what we're actually going to be returning, even though our return type is just the to-do list repo. And then down here, inside of that, we need to hand it some parameters. So db.dow, and then API and our dispatcher. Now let's go ahead and run that again and see how that looks. Oh, I need to actually write return there. And let's go ahead and click that again. And there you go. You can see it installed. It even loaded all the data in, so that's working. Our padding looks a little bit off here. Let's go fix that. So if I go into my to-do list screen, this to-do item card, it looks like we forgot to pass our padding on the modifier. So let's add a little bit of padding to that, maybe 4 data pixels on that. Okay, there we go. That looks a little bit cleaner. Let's try to toggle one of these. Oh, that color is a little bit off. We can fix that. Let's go check our online database. And you can see here, item 0. Item 0 is rake all the leaves. So maybe let's find rake all the leaves here. I guess I have these ordered differently. Oh, yeah, look at that, the last one. So I'm going to go ahead and toggle that and check the online database again. And you can see here, completed did in fact toggle here. Let me pull this phone out so that we can see both of these at the same time. So now if I toggle rake all the leaves, let's try, okay, let's try deleting one of these. So to do that, we're going to switch our order here. So we'll go by maybe title, we'll sort down, and we will show the archived. Now let's pick one of these, maybe apple picking. So in here, we need to find apple picking. I guess I could just do rake all the leaves again. This is what I get for doing 30 of them. I should have just done maybe 10. So here's my rake leaves. Let's try to archive that. You could see archived switches to true, so that's working. Let's unarchive that. Let's try deleting that. And there you go, it's gone. Now if I undo that and add that back in, there we go, rake all the leaves is back again. So that's working as well. If I click on that, nothing happens. And that's because we haven't defined that function yet, because we haven't actually built our second screen. So you can see our device is running and it is working with our real-time database online. There's one thing I want to fix here, and it's that green color. So let's go into our presentation, into our UI colors. And then in here, let's find our, which one was it? We can check, go to core, presentation, components, get to do colors, and our check color, if it's completed, is going to be color scheme tertiary container. So come back down into our color, find our tertiary container, and let's replace that with just a little bit darker green, maybe this color right here. So that looks pretty good. And we did that in our light theme. Let's do that in our dark theme values as well, just so that we have that same color on the checkbox either way. So on tertiary, let's see, tertiary container, I'm going to replace that with that same green, run that one more time. And that's just because we're going to want a green that looks good. There we go, that's a little bit darker. You can see that better. And if I archive that, you could see, you could still see it decently well on that. So I think that's pretty good. Next, let's go ahead and double check our sorting menu, which is a little bit bigger than we want it to be. So we need to fix that. Oh, what was that? So if I click on time and then click select down, you can see that pops up. So something's not quite right. Let's go check our copy function on our item order. So come into components, or not components, where did I have that? That's in domain, util, this one here to do item order. And okay, so here we have title, copies to title, time, copies to title, and completed copies to title. So we need to fix that. Time needs to copy to time, and then completed needs to also copy to completed. Let's go ahead and fix that spacing too. So if we come back into our screen file, and let's find here our navigational drawer. Essentially, we're going to want to change that, and pretty much we're going to put this whole thing inside of a box, and then inside that box we're going to pass in a modifier with some weight to it, and then we'll be able to adjust the size of this drawer based on the weight that we pass in. So to do that, I'm going to say box, and then inside of the parameters, I'm just going to say modifier equals a modifier dot. We're going to do fill max width, but instead of leaving that empty, we're going to hand that a float value. So we'll say .65 is going to give us 65% across the screen. And then after that, we need to actually copy pretty much this whole thing. Well, don't copy it, actually cut it, paste it inside of that box. And now let's run that one more time. Pull up that menu, there we go. Now you can see we only have half the screen, and if I change that, the checkbox up here doesn't jump around. If I turn off my archived and then turn it back on, everything seems to be working. If you're still following along with this video, you've just made it now to checkpoint number 7. We've just finished out our list screen, and now it's time to go ahead and build that add or update screen. So if you're just joining us, you can grab that code from the description for checkpoint number 7. Or if you're following along and your app looks a little bit different, you can compare your code to mine at that same GitHub link down in the description below. Now let's go ahead and do that new update screen. So I'm going to close my to-do list package, open this new update package. We're going to do a new Kotlin class or file. This is going to be a data class for the state. And I'm going to call this to-do new update state. And in here, we need to track a couple different things. First, if I click on one of these, or rather, let's just make a new one. If I have a new one, you can see I have a title field here and a description. And if I click on that, it disappears. If I click on that, it disappears. If I type something there, it doesn't come back. So I need variables in my state to track that. So I'm going to say val is title int visible. and that's going to be a Boolean by default equal to true. I'm also going to say val is description int visible, which is also going to be a Boolean equal to true by default, because when I make a new item, I want both of those hints to pop up so that the user knows what to type there. Then I'm going to have a to-do item in here. So val to-do of type to-do item. And that to-do item is going to be equal to a new to-do item. And then inside of that constructor, we need to pass it our fields that are required for that. So title is going to be equal to an empty string. My description is going to also be equal to an empty string. My timestamp is going to be equal to 0 for now. And then we're going to say completed is going to be false. And then also archived is going to be false. And then our ID is going to be null, because that's going to be set by the room database. So until we actually save this item into room, we don't have an ID. So that's going to be null for now. And then after that, I'm going to have the same thing I had on my other screen, which is a isLoading variable for if we need to display that circular progress indicator, which is going to be a Boolean by default equal to true, because when we first load this page, it's going to be loading, and then val error is going to be a string, which is nullable, which starts off as null because we don't have an error. And finally, we're going to say val current to do ID is a nullable integer, which is of course going to be null because again, that's set by a room database. So that's going to be everything that we need for the state. Let's go ahead and make a class in here for any events that we'll need as well. So this is going to be a new Kotlin class or file sealed class. And again, because we have a finite number of events that we can do, we're using a sealed class, and we know what all of those are ahead of time. So I'm going to say sealed class. We're going to name this to do new update event. And then inside of here, we are going to say data class entered title. This is going to take a value that's going to be a string, and it's going to return back a to do new update state. Then we're going to have data class entered whoops, what's wrong up here? Data class entered title val value string return to do new update state. We want this to return a to do new update event. Okay, entered, not entered, we're going to say change title focus, and this is also going to be a val focus state, which is going to be a focus state. And then this also is going to be a to do new update, not state, but event. You always got to check those autofills. Sometimes they give you the wrong thing. Data class entered. These two are just going to be the same. Actually, let me just copy those two, paste them here. And then instead of title, we could say entered description. And then instead of title down here, we can also say description. Okay, so we've got that. Then we also have our delete button, our archive, our toggle, and then our save button. So to do that, I can say object delete, which is going to be a to do new update event. Then I have object toggle completed, which again, new update event. And then we can toggle archived, object toggle archived. And again, this is a to do new update event. And then we have an object save to do for if we hit that save button. And finally, the last thing we have is that back button up there. So let's go ahead and make one for that. So object back, and then this is going to be the same thing. Pick the event, not the state. And that should be everything that we need in the event. Let's go ahead and build a view model for this class as well. So we're going to say new Kotlin class or file. This is going to be a class, and this is going to be our to-do new update view model. And then inside of this view model, basically we're going to do the same thing we did with the other one, where we annotate this with @hilt view model, and then we're going to do an injection constructor, we're going to inject our dependencies in the constructor. So inject constructor, and then inside of this constructor, we're going to need our to-do use cases. So we can say private val to-do use cases, and then that's going to be of type to-do use cases. And then after that, we need a saved state handle, and basically the saved state handle is what we're going to be using to pass in parameters for when we're calling that from our nav controller, because when I click on one of these, I need to actually know which ID we're pulling so that we can display the proper element to the user. So that's what that saved state handle is going to be for. And then finally, we're going to have a private val dispatcher, which is going to be a coroutine dispatcher. And I'm going to annotate that again with our IO dispatcher annotation. And that should be everything we need for the constructor up there. This needs to inherit from our view model class. And then inside of here, let's go ahead and determine all of the variables that we're going to need in here. So we need our state again, obviously. So to do that, we could say private val underscore state is equal to a mutable state of, and then this is going to be our to do new update state. And then this is our private variable, so we need our public access for that. So to do that, I could say val state is equal to a state of type to do new update state. And then this is just going to be equal to underscore state, which is our private variable up top. And then after that, I'm going to need a couple more things. I'm going to have an error handler, just like I had in the other one. So to do that, I'm actually just going to copy my error handler from here. That should be all we need right there. So in here, paste that error handler, and we should be good to go with that. Now, I'm actually going to need to collect UI events, or at least emit UI events that I can send back to my UI so that I can instruct it to do things like navigate, because that's where our nav controller is. And I can also instruct it to do things like display a snack bar, because again, we don't have a snack bar inside of our view model. That's going to be inside of our screen itself. So to do that, we're actually going to need another event class. And this one I'm actually going to put inside of my view model. So this is going to be a seal class UI event. And then inside of here, we need to put everything that pretty much any event that's going to happen where we need the screen to do something like display a snack bar or navigate, we need to put in here. So that way we can pass that data back to the screen. So data class show snack bar val message. This is the message that's going to be displayed on the snack bar. And then this is going to be a UI event. And then object save to do. This is also going to be a UI event. And let's see, finally, object back. And this is going to be a UI event. And you may be wondering, don't we already have in our other event class that we just made, we have a save to do, we have a back. So what's up with this other class? And basically, like I just said, we're going to put all the logic that the view model needs to handle in our onEvent function down here, which we haven't made yet. So it's going to say fun on event. And then in here, we're going to handle anything that happens from these events. But if we have some of these events like back or save to do that are going to need to access things that our view model doesn't have access to, like our nav controller, then, or even the snack bar, then in here, whenever we handle this back event, we also need to emit this back event so that then my screen can actually call the nav controller to go back. So that being said, we're going to need to put an event flow in here as well so that we can emit these events when they happen. So to do that, I could say private val event flow equals mutable shared flow, and this is going to be of type UI event. And then same thing here, our private one is with the underscore, and then our public access one is going to be without an underscore. So we say val event flow is going to be equal to underscore event flow dot as shared flow. And make sure to import that. So with that, actually, before we go on, let's go back to that state. Because we're never going to actually need this current to-do ID from our UI, I'm actually going to put that just in the view model itself instead of in the state. And then in the view model, I'm just going to have here private, and whoops, I guess I lost that. We're going to say private var current to do ID, which is going to be a nullable int that we set equal to null initially, and then we'll set that whenever we get a response back from room. So now, before we do our on event, there's one more thing that we have to do, and that's going to be our init function for this view model. So let's make an init block, and then in the init block, we're going to say saved state handle. And this basically we need to get the ID for the item. So we're going to say dot get, and this is going to be an integer that we're pulling in. And we haven't named this yet, but I'm going to name it to do ID. And then let's go ahead and insert non-null and say let ID. And then we're going to say if ID is not equal to 1, then in here, we're going to go ahead and do view, or actually, yeah, if ID is not equal to -1 is what we're going to want, because that's just going to be our default value that I'm going to use back when I make my nav controller. So we can do view model dot, view model scope dot launch. Import that, and now inside of here we can say to do use cases dot get to do item by ID. We're going to hand it that ID, and then say also to do, and then down here we're going to say current to do ID, set that equal to our ID that is coming in, and then after that we're going to update our state, so we can say state dot value equals state.value.copy. And then in here, I could say to do equals our to do is loading is going to be equal to false, is title hint visible is going to be equal to do dot title dot is blank. And then is description hint visible is going to be equal to do dot description dot is blank. And now that we have that, let's actually go set up this route over in our main activity file, just so that you can kind of see what and why we're doing here. So if I come back into the main activity here, and then down here in this to do, we need to populate that with the route that we want. So let's delete that, and we have screen to do new update screen.route. We need to add to that. So I'm going to say plus to do ID is equal to do ID. So that's the ID that we're going to have coming in here. And then down here, we need to say, actually, let me just space this out a little bit better. We'll have our route. And then after the route, we have our arguments list of, and then this is going to be a list of nav argument. And then inside of there, we need to tell that the name. So this name is a string, and it needs to match this ID right here to do ID that we put in our view model. So let's copy that, come back here, paste that inside of the name. So name equals to do ID. We need to give a block to this one, and we could say type equal to nav type dot int type. And then after that, we can say default value equals -1. So this -1 here being set as the default value, that means if I come in here and I click on one of these, it's going to hand me the ID that's associated with that one in our database. But if I click new, it's going to give it a default value of -1, which means in the view model, if the ID does not equal -1, we need to run that code. But if the ID does equal -1, we don't need to load in any to-do item, but we do need to update our loading. So we can do state.value equals state.value.copy, and then basically is loading equal false, and that should be all that we need there. And then back in main activity, we have this, right here, we need to set our, well, actually, we don't have it yet. Essentially, we need to call our final screen from here using our nav controller, or passing in our nav controller. So to do, and we'll come back to that. So now we're done in main activity. Let's go back to our view model now. And now in our view model, we've got our entire init block set up, which means the only thing left now is going to be our on event. So we're going to pass in an event of to do new update event. And then in here, because this is a sealed class and I like pairing sealed classes in when statements, let's go ahead and do that. When event. And then this is of course going to give us an error. So we're going to say add else branch. Whoops, not add else branch. We're going to say more actions, and we're going to add remaining branches. So now we have all of the branches. Let's go ahead and give a body to each of these, and then we'll come back and fill them in. Okay, so let's go ahead and fill these out now that we have all of these done. So for back, this is going to be fairly easy. We can just say view model scope dot launch, and then make sure to hand it that dispatcher and our error handler, which actually I might need to do that above too. Let's copy that, come back up here, make sure to put that there as well. Now here in our event, all we're gonna do, because we don't have access to the nav controller, if somebody clicks that back button, all they wanna do is return to the main screen. So we are gonna go ahead and emit an event flow dot emit UI event dot back, and then we'll go ahead and handle that in the screen when we make that. Okay, now for the rest of these, we can do, okay, so for change description focus, we're going to say val should description int be visible, and this is going to be equal to not, this is going to be equal to not event dot focus state dot is focused and state dot value dot to do let's see, description dot is blank. So if both of those are true, we want to show it, and that's kind of a mouthful, which is why I put it in a English variable that you can read, because that's going to make it easier when we come back to review our code and see what this is doing. So state.value is going to be equal to state.value.copy. And then inside here, all we have to say is description hint visible? And this is going to be equal to should description hint be visible? Now, let's go ahead and do, where's our other one for change description focus, change title focus. This should be pretty much the same thing. So I'm going to go ahead and, well, I'll just retype it. Val should title hint be visible is going to be equal to not event dot focus state dot is focused anded with state dot value dot to do dot title dot is blank. And then again, if we have both of those, we can come in here and say state dot value is equal to state dot value dot copy, and this is of course just going to give us our same state back, except we want the is title hint field to now be equal to should title hint field be visible. So we've got all of that. Now for entered description and entered title, those are also going to be fairly similar here. So for entered description, we can say state.value equals state.value.copy. And then inside of this copy, we can say to do equals state.value.todo.copy, and then content, or description rather. And then description is going to be equal to event.value. Okay, now let me go ahead and copy that one because our entered title is going to be pretty much the same. The only difference here is we're going to do title equals event.value this time. So that should be good. Then after that, we've got our save to do. So this one's going to be a little more complicated, but let's dig into that. We're going to have a view model scope, and we're going to pass that our dispatcher plus our error handler. And then, oh, actually, that needs to be view model scope.launch. Pass that, the dispatcher and the error handler. And then inside of there, we're going to say try. And in here, we're basically going to launch our use cases. And if those use cases don't work, then we're going to say catch E, which is going to be an exception. And then inside of our catch block, basically we need to do event flow.emit. And this is where we're going to make use of that snack bar, because if we have an error here, we want to tell that to the user. So UI event dot show snack bar, and this is going to be message equals e dot message. And then we'll do the Elvis operator and say new new update. Okay, so we're going to do new update strings dot, and we'll make one called save error. But before we can do that, we have to go back to our constants file, which is going to be in our core util to do constants. And we need an object for this screen. So I'm going to say object, paste that, and then inside here I could say save error, and that's going to be equal to unable to save to do, ensure the title and description are not blank. Whoops, no E on the end of blank. Okay, there we go. And this actually needs a const val. Okay, now that we have that, come back here and we can say new update strings, go ahead and import that. So we're going to pass the snack bar a message from our exception, and if that doesn't exist, then we're going to pass it that error that we just put into our constants file. So that's how we handle our exception, but now we need to handle what to do in the try catch. So I can say if current to do ID does not equal to null. So in here, if our current ID is not null, that means that we're updating one and we're not adding one. Then I can say to do use cases dot update to do item, and then this is just going to be state dot value dot to do. And then we can say else, meaning if our current to do item is equal to null, that means instead of updating, we're adding one. So now we want to run our add use case. So we can say to do use cases dot add to do item. And then this is going to be state dot value dot to do dot copy. And then in here, we need to assign a timestamp. We can say system dot current time in millis, which is going to hand back a long, and then we can say ID equals to null. And then we'll handle that later. So that should be everything we need for saving it. But once we save it, we need to also navigate back. And to navigate back, we need to make use of our nav controller, which is not in the view model. That's going to be in the screen. So I'm going to say event flow dot emit. And then this is going to be a UI event dot save to do. And then we'll handle that in the screen, telling it whenever you see a UI save to do, go ahead and navigate back to the list. Okay, what do we have left? Toggle archived and toggle completed. So these, again, are going to be fairly simple here. So for toggle archived, all that we're going to want to do is state.value equals underscore state.value.copy. And then inside of here, we could say to do equals state.value.todo.copy. So we're going to take our current to do in our state and we're going to copy it. But the archive is going to be the opposite of what it is. So we can say not state.value.todo.archived. Okay, let's go ahead and copy that because for toggle completed, it's going to be pretty much the same. So the only difference here is we're going to say completed is equal to not state.value.todo completed. So those are done. We only have one left, I believe, which is this delete. So let's go ahead and do that. To delete one, that's going to be a suspending function. So we need a view model scope. So view model scope dot launch. And then this is going to be our, I'm going to say dispatcher plus error handler. And then inside of this block, I can say if current to do ID is not equal to null, then all we need to do is run our to do use cases dot delete to do item. And then in here, we can say state dot value dot to do. Okay, so if it's not equal to null, the ID, then we want to delete that one out of our database. But if it is equal to null, we actually don't need to do anything other than navigate back to the list because we haven't saved this yet. So at this point, all we need to do in here is say event flow dot emit UI, let's see, UI event. It helps if you can type dot back. Okay, and that'll get us out of here. So that should actually be everything we need here. Now we can actually start building out the screens. So to do that, if you look on this screen, you can see we've got, basically you can tell we have a scaffold here. And we've got the top app bar, we've got a bottom app bar with a bunch of action icons and then a floating action button. And then in the screen itself, it's pretty simple. We just have these two text input fields. But because we have that hint that you saw on there, right? So if I click down there, I have a hint. And then if I click on it, it goes away. I'm going to need to make a custom component to handle that. So to do that, we're going to come into our components category and we're going to make a new one. I'm going to call this new Kotlin cluster file, and this is going to be our hint text field. And then inside of this hint text field, whoops, I don't want to do that. This actually is going to need to be a file, not a class. So Kotlin cluster file. I guess I could have just deleted that that class out of there, but whatever. Hint text field in a file, and basically we're going to have a composable in here, and this composable is going to be fun int text field, and then inside of here, let's give that a body so our error goes away. We're going to need a few different parameters passed in. We need a modifier of type modifier, and by default I'll have that set to just a standard modifier. Text is going to be a string. We're going to need a hint, and that's also going to be a string. We'll need a font size, which I'll set equal to text unit, and by default we'll say 32 SP, and then we'll need a text color, because this is going to change depending on if we're archived. It needs to be white so that you can see it, and if we're not archived it needs to be black or maybe a really dark gray so that you can see it. So text color, and that's going to be a color, and then after that is int visible, and this is going to be a boolean, which by default I'm going to have equal to true, and then we're going to say single line boolean is equal to false, and that way we can have this be a single line for the title if we want, or multiple lines for the body, so that we can use the same hint text field for both of them. And then we need a few things. So on value changed, this is going to be a string function, and we'll pass back a unit. And then on focus changed, which is going to be a focus state function, and that's also going to pass back a unit. Okay, now inside of this function, basically we're going to do a box, and then inside of that box we're going to put a basic text field. So box import that, and then I'm going to set the modifier is equal to the modifier that comes in with our parameters. And then finally down here we can say basic text field, and then in here we're going to say value equals text on value changed is going to be equal to on value changed. I'm going to say single line is equal to my single line parameter coming in. Text style is going to be equal to text style, and then inside of text style we can specify our font size, which is going to be equal to the font size parameter, and our color, which is going to be equal to our text color parameter. And then let's get all those imports. Okay. And then after that I can say our modifier is going to be equal to a new modifier, and this one we're going to say dot fill max width, and then we're going to say dot on focus changed, and then in this lambda I'm going to pass that on focus change function with it. Okay, there we go. That should be all that we need for the basic text field. But now beneath that, let's go ahead and do our logic for if the hint should be visible or not. So if is hint visible, then inside of here we need to have a text, and that text is basically going to be our hint, and it's going to be text equal hint color is equal to text color, and then font size is going to be equal to our font size. So import that. And now this is totally done. We should have everything that we need to build out the actual screen. So close out components, we're going to do new. In here, this is basically going to be a composable function that builds our screen. So we could say fun to do new update screen. And then inside of here, I'm going to pass this a nav controller. And this is going to have a view model of type to do new update view model. And by default, we're going to set that to a hilt view model and then give that function a body. And before we forget, while I have this here, let's go back to our main activity. And then in main activity, let's go ahead and get rid of that to do. And we could say to do new update screen. This one is with a nav controller equal to our nav controller that we have already. So now main activity is done. Close out of that. Come back into your to do new update screen. And in here, we're going to need a few variables. So first of all, val state is going to be equal to view model dot state dot value, and that'll give us our state. And then in here, we can say val, because we're going to be hosting a snack bar. If, for example, like this is empty on the title, if I click save, we need to display the snack bar. So we could say val snack bar host state is going to be equal to remember, and this we're going to remember a snack bar host state. Give that a constructor, and then make sure to import that remember. And then our scope is going to be equal to a remember coroutine scope. And then we need some colors because, again, if I toggle this, you could see my whole color scheme is changing, and also the color for that changes for my completed button. So we can say val to do colors is going to be equal to get to do colors, and then our to do is going to be equal to state.todo. And then after this, again, because if we rotate this screen, we're going to display a different background image. We need to know if we're in portrait or landscape mode. So I can say pretty much what we did in our other one. In fact, let me just copy that. So if I come into my where is it? To-do list screen, come all the way up top, this one, configuration is portrait, and then all of this. I'm going to copy all of that, come back into here, paste it, and now we've got the background set with all the colors and everything. And then in here, we're going to have a launched effect block as well. And this launched effect block is going to be where we handle anything that was emitted from our view model. So this is going to be true, and then key one equals true. Let's see, view model dot event flow dot collect latest, and then in here I can say this is going to be an event coming in, and then in here I can say when event, because again this event is a sealed class and it pairs nice with a when, and I can just come out here, more actions, add remaining branches. Okay, so if it's back, all we're going to need to do is say nav controller dot navigate up, and then if it's save to do, same thing. All that we need to do is say nav controller navigate up. And the reason for that is because all of the saving logic that was handled by the view model, that was already performed. So all we need to do at this point is go back to the last screen. So navigate up, and then if it's my show snack bar, then I need to do snack bar host state dot show snack bar, and then my message in there needs to just be message is equal to event dot message, and that should handle every state or every UI event that comes back that we emit from our view model. So now after the launched effect, I can actually start building this UI. So the first thing I'm going to need is a scaffold. Let's give that a constructor. Okay, and we're going to pass that a padding value because it likes it when I do that. We better suppress that. Actually, I don't want to suppress it there. Let me grab that. Let's see. Let's just grab all of that stuff, come back in here, suppress all of that up here. Okay, now in this new scaffold that we have, the first thing that we want, well, we've got the top app bar and then the bottom app bar. But if I rotate this, you can see my top and bottom app bars actually go away to make room for all the text so that you can still see it, but my floating action button does not. So what this means is I'm going to have essentially I'm going to have a floating action button on the bar down here, and then the same floating action button off the bar that needs to be visible if I rotate the screen. Which what that means is we can say scaffold floating action button equals, and then in here I can say if not is portrait. So if we're not in portrait, if we're in landscape, then we're going to display this floating action button. So that's going to be a floating action button. And then let me space this out a little bit. I'm going to say onClick is equal to my view model dot on event, and then this is going to be a to-do new update event dot save to do. Okay, and this is going to be, let's see, we're going to make that a circle. So shape equals circle shape. Container color is going to be equal to material theme dot color scheme dot primary. And then inside here, I'm going to have an icon for that plus sign. The image vector is going to be icons.default.save. And then my content description, here, let me space that out, and then we'll go add a constant for that. So that's going to be one called save to do. That's going to be content descriptions dot save to do. So let me copy that, come up into our constants file, find our content descriptions in here, const val save to do equals save to do item. Okay, now let's go back to that screen, not that screen, back to this screen, and we've got that icon, we've got the save to do, but actually there's one more parameter here, and that's going to be tint is going to be equal to material theme dot color scheme dot on primary. So this is the tint for the icon. And then this should be totally good to go. So let's get to the end of that floating action button. And then after that, we need to add our top bar. So this is going to be top bar is going to be equal to our function in here. And again, we're going to do if is portrait. And then in here, I'm going to say a center aligned top app bar. And let me just space this out a little better. Okay, so our title is going to be equal to text, and then inside of here, whoops, import that. Inside of here, I'm going to say text equal to do list strings dot to do list. And then our max lines for this is going to be 1 because it's a title. Plus, we know what the text is, so we're never going to overflow that. So overflow, I'll just set to text overflow ellipsis. Again, we're never going to overflow this, but if we ever wanted to use this code, it might be nice to have some of these. Style equals material theme dot typography dot headline medium should be good. I think that's what we used on the last one. And then color is going to be equal to material theme dot color scheme dot on primary. Okay, so that should be good for our title. But after the title, there's more parameters that we want. We need to do our colors. So our colors is going to be equal to top app bar defaults dot center align top app bar colors. And then in here, I have a whole bunch of them that I need to define. And I'm pretty sure we already did all of these in our to-do list screen. So let's scroll down to our top app bar, scaffold, top app bar. Here we go, top app bar colors. So let me copy all of that, come back to our to-do new update screen, and we have our primary with an alpha, primary, on primary, and then on primary finally. So that should be good. Now we can go ahead after colors, we can do our navigation icon. So our navigation icon is going to be equal to an icon button. We'll do that one, and then space those out a little bit. And then this on click is going to be equal to view model dot on event. And this is going to be a to do new update event dot back. So this is our back icon. And then we'll hand a modifier to that as well. So not there. We need the modifier in here. So modifier equal to modifier dot. I'm just going to get that a little bit of padding at the start. Make sure it doesn't get too close. Maybe 8 data pixels should be good. Inside of there, we need an icon. And this is going to be an image vector, which is equal to icons.default. We're going to say arrow back. And then content description is equal to content descriptions dot. This needs to be back. So I don't have that. Let's go back to our constants file. And in here, I can say const val back equal to back. And then back to our new update screen. We're good there. Import our padding. And then after that, we need a color on this. So I can say tint equals material theme dot color scheme dot on primary. And then, okay, after that, we need our actions, which in this case, you can see I don't have any. So we're just going to leave that empty. Our actions are empty. And then our scroll behavior is going to be equal to top at bar defaults dot in scroll behavior. And then I'm going to say remember top at bar state. And essentially we can't scroll here anyway, but that's just going to leave it locked up there. And then after all of this, so after our top app bar, which is this one, now we can put in our bottom app bar. So bottom bar is going to be equal to if is portrait. So we're checking the orientation of our phone, because if you remember, we have this bottom app bar and the top app bar, but if I rotate my phone, now the bottom app bar and the top app bar has gone away. So the only thing that we're going to keep is this floating action button. So let's go ahead and put that back. And now in here, if it's portrait, we want to display our bottom app bar. So to do that, in here, all we have to say is bottom app bar, and we can get rid of this body. We only want a constructor here. And then inside of the constructor, we have to give it the actions, which I'll leave blank for now. But that's basically going to be these 3 action buttons down here, our complete checkbox, our archive, and then finally our delete box. And then after actions, we have to hand this a floating action button. And then finally a container color, and that's the easiest one. So let's go ahead and do that. Material theme dot color scheme dot background. And we're going to say dot copy because we want to put an alpha in there as well. So alpha is equal to 0.5 F. And that way it's going to give it this nice see-through look so we can still see the background behind it. And now for the floating action button, all we have to do, and what is this error? We don't want that comma there. So for the floating action button, I'm actually just going to take this floating action button that we already have, copy that, and then we can paste it inside of here. And basically, so the material 3 guidelines say that if you have a floating action bar and a bottom bar, you want the floating action bar to be on that. But if you don't have a bottom bar, you want the floating action button obviously just to be floating. That's why we're saying if it's portrait, then we're going to go ahead and put this floating action button on the app bar. But if it's not portrait, as in this case up here, then we're going to make a floating action button independent. And the reason we're doing that, obviously we could just do that and leave the one on the bottom app bar blank, but you want the floating action button to be on the bar, not above it. That's just the Material 3 guidelines that they put out on their website. You're welcome to check out all of those guidelines. It's down in the description below. But now let's come back to here and we can go ahead and fill out our actions. Like I said before, that's just going to be these 3 buttons down here, the complete check, the archive, and then finally the trash can. So to do that, in here, all we need to do is add a complete button, and that's going to give us all the parameters that we need to put in there. I am just going to space these out a little bit more. So completed is going to be just simply state.todo.completed. So state.todo.completed. And then our color is going to be saved in the to-do colors that we fetched earlier. So to-do colors dot, and I'm going to say check color. And then our onComplete kit click, this one is just going to be a function from our view model dot on event, and this is going to be a to-do new update event dot toggle completed. So that's what we need for the complete button. Then our archive button, this one is going to be also very similar. So I'm just going to copy that view model event up there. Now in here, delete the to-do. Let's go ahead and paste that. So instead of toggle completed here, we're going to say toggle archived, and that's all we need for that one. Now, after the archive button, we can go ahead and say delete button. And in here, again, we need to give this an on delete. So on delete click. And then in here, I'm going to actually launch a coroutine. So scope.launch. And the reason that we need a coroutine for this is, of course, if we're deleting something that's in our room database or on the network in the Firebase database, we need a coroutine to go ahead and do that. So val confirm equals, and that confirm is just going to be the result of this snackbar host state dot show snackbar. And then in here, we need a message, which is going to be equal to something that we haven't set yet. So I'm going to say new update strings dot, and then we'll come back to that. And then after the message, we need an action label. And that also is going to be new update strings dot. Now let's go into our to-do constants and actually add those in here. So I'm going to have one called const val confirm delete. And that's just going to say, are you sure you want to delete this to-do item? And then I'm going to have another one in here, const val yes, and that's just going to equal yes. Okay, so now we come back here, our to-do new update strings, this is going to be confirm delete, and then the second one is going to be yes. And then after the action label down here, we can say if confirm is equal to snack bar result action performed. That means if, for example, I click delete, then I get this snack bar if I click yes. So that's what this if is looking for. Then in here, I can say view model dot on event, and this is going to be a to do new update event dot delete. And that should be everything I need for this scaffold. So now we can come down here into the body of our scaffold and actually build out this composable function. So the first thing I'm going to do, like I did in the last one, is I'm going to build a box. And then inside the parameters for this box, I'm going to go ahead and let's do content alignment equals alignment dot top start. And then after that, I'm going to say modifier equals modifier. We're going to say dot fill max size. And then after, whoops, I need a comma there. And then after fill max size, I'm going to say dot background, and then color equals to do colors dot, and this is going to be background color. Okay, so now within that box, the first thing that I want to do here is I'm going to add an image, and this is basically going to be our background image. So we can say image, and then in here, we can say painter equals painter resource ID equals background image. And then after that, I can say content description is going to be equal to content descriptions dot. We should already have one in here for background images because we did that in the last one as well. And we do, so content scale is going to be equal to content scale dot, and I'm going to say fill width. And then after that, I'm going to say modifier equals modifier dot fill max size. And then our alignment here is going to be equal to alignment, and this is going to be dot top start. And so the reason we're doing that, whoops, lowercase a alignment. So the reason I'm doing fill max width for my scale is that's going to keep my image locked to the sides of the screen. And then if I do top start, that is going to make it locked to the top and the sides. So then I have wiggle room on the bottom to move stuff around. And the reason that's important is if I were to click in here and bring up my keyboard, well, now you can see all this shifts up. I don't want my entire background to shift up with it. So that's why I have this content scale and this alignment set that way. And then after this image, we can go ahead and build a column. And then in here, I'm going to say, in here, let's give that a block to make that error go away. Basically, I'm going to need some padding values in here, but that's going to change depending on if I'm in portrait or landscape mode. So I'm going to come up here to where I'm defining all my variables that have to do with that. And I'm going to add a few more in here. So val top bar height, and that's going to be equal to, if it's in portrait mode at least, that's going to be equal to 64 data pixels, which is the height of the top bar according to their Material 3 website. And then 0 if we don't have, if we're in landscape mode, because we're not going to have that bar at all. And then I can say val horizontal padding is going to be equal to 16 data pixels. And that's not going to change because that is just how we want the side of the screen padded. But the vertical, however, will change. So vertical padding, and this is going to be equal to if is portrait, and then I could say 16 data pixels, else 2 data pixels. And if I really wanted to make more room in here, I could also add some text values or some font sizes in there as well. But I don't think we need to do that right now. So come back down to your column. And then in here, we need to go ahead and start adding these values. So I can say modifier is equal to a modifier. And then after that, we're going to say dot padding. At the top, we are going to start the distance of our top bar height. So top equals top bar height, and then fill max size, because we want this column to fill up the entire screen. And then inside the column, basically, we're going to need to have 2 hint text fields with a spacer in between. And that's exactly, if you look here, we've got our title, which is going to be a hint text field, and then our body, which is going to be another hint text field, and there's a little bit of space in between the two of them. So here, for the text, all I need to do is say state.todo.title. For the hint, all I need to do is say new update strings, but we don't actually have one for this. So go back to the to-do constants, const val, and this is going to be our title hint, which is going to be equal to title dot dot dot. And then while I'm here, I'll do const val description hint, which is going to be equal to description dot dot dot. Okay, now back in the screen, we can say new update strings dot title hint. Our text color can be equal to do colors dot text color, and then our on value change. This is going to be a lambda. We're going to say view model dot on event, and then in here we have a to do new update event dot entered title, and then we'll pass it. And then in here on focus change, we can say, let me fix that spacing again. Another lambda, we can say view model dot on event to do new update event dot, and this is going to be a change title focus again with it. Okay, now we've got all of that. We need is int visible. This is going to be state dot is title hint visible. And then we can say single line is going to be equal to true because this one's our title. We, let's see, let's give this a font size, and that's going to be equal to 40.sp. And then we'll say finally a modifier is equal to a modifier dot padding. And then for these padding values, I'm going to give it that horizontal and vertical padding that we defined. So, whoops, horizontal equals our horizontal padding, and then vertical is equal to our vertical padding, and that's the one that's going to change depending on if we're in portrait or landscape. And after that, let's copy all of that because I'm pretty much going to paste it and use most of that again. We could say spacer, it's a modifier, which equals to modifier dot height. And then in here, I can say vertical padding. Make sure to import all of these functions. And after the spacer, let's go ahead and paste that in there. And we can say state equals to do dot, instead of title here, we can say description. Instead of title hint, we can say description hint, should that be? Come back here. Yeah, let's make that hint. So back in here, that should actually be description hint. And then our text color's fine. In here, this is no longer entered title. This is now entered description. This is no longer changed title focus. This is now changed description focus. And then state, we don't want is title visible. We want is description hint visible. Single line is going to be false now. And let's leave the font size at the default that we had already set for that. And now finally our modifier, let's see, we do want some padding in there. But before that, I'm going to say fill max height. Whoops. Fill max height. And then in our padding, we are going to leave, let's see, horizontal and vertical padding. That should all be good. So really, I think now we're pretty much done with this app. Let's go ahead and run this and see what it looks like. Okay, there we go. Looks good. Let's click on one of these. Oh, yeah, okay. Anticlimactic. Don't keep your fingers crossed. So there's one more thing that we actually need to do. We need to come into our list screen. And if you'll remember, we left a to-do in here, which was here. On card click, we need to run our navigation. Screen dot to do new update dot route, And then we need to add to it the route from our main activity, which is going to be this here, except I don't want the spaces. Let's get rid of those. Copy that, come back to to-do list screen, paste that route, except the only difference here, well, first of all, we want that inside quotes. And then we no longer have this to-do ID parameter, but we do have to-do .id, so I'm going to use that one in there. And now that we have that, I'm guessing if I didn't do that, I probably didn't do my floating action button either. So come up here, and sure enough, to do, let's go ahead and do onClick equals nav controller dot navigate, not navigate up, just navigate, and we're going to say screen dot to do new update screen dot route. Okay, run that now. Now let's click on one of these and try to edit it. And you'll notice our keyboard popped up, but our bottom app bar didn't, and our floating action button didn't. And that's really annoying because now I can't click to save this without getting rid of the keyboard. So I'll show you how to fix that in a second as well. Hit save on that. And look at that, our edit did in fact work. While that's going, come into the Android manifest. Down here, we're going to add a new one here, which is this one actually, Android Windows soft input mode equals adjust resize. And now if I run that again and click on one of these and bring up my keyboard, you can see the bottom app bar moves up with it. But the background, it actually did resize the background, but because I had the background to fill max width and then to have the start fixed at the top of the phone, even though it resized, it just cut the bottom of it off and it didn't move. So it looks much smoother if you do it that way versus if it resizes the background and moves it around. So let's hit back on that. Let's try to add a new one. So ABC, just alphabetically so it shows up at the top of our list. Hit save on that. There we go, ABC is there. So we can click in one of these. We can toggle the checkbox. We can toggle that. We can click delete, and delete actually doesn't work, and that's because there's an error that we're going to need to fix. So in my repository implementation, we've got our delete to do items, and we do delete from our API, but we've never deleted that from our DAO, meaning our room database. So I'm going to go ahead and do that as well. Delete to do item to do dot to local item. And now if I run that one more time, we should be able to delete our visit a farmer's market. So I click on that, and I can in fact, nope. Delete it from there. Okay, I found the reason why it's not working. Basically, we set this right in our delete button, and we're launching our snack bar host. And then once the snack bar comes up, it asks for whether you want to actually confirm this delete or not. And because we're waiting for that confirmation before we run our delete event in our view model, it's never going to actually delete it. And the reason for that is because this snack bar, you'll notice, wasn't appearing on our app. So if I click in here and click delete, the snack bar never comes up. And that's because there's one more parameter that I need down here on my scaffold, and that's going to be our snack bar host, which is equal to a snack bar host. And then in here, I'm going to say host state is equal to snack bar host state. And now if we run that and I click delete, that snack bar should come up, which should then give me the option to actually delete an item. So if I click on that and now click delete, are you sure you want to delete this item? Yes. And there we go. It's been deleted and it's gone. So that's really all that we needed to cover in this video. We have this app now with our to-do that's syncing with both a local room database and then a remote real-time database on Firebase. We have the updates. We have 2 screens with navigation in between, the archive, the delete, the sorting. Our UI is built and everything is looking good. So hopefully you've enjoyed this video. Hopefully you've learned a lot from this video. If you have, definitely leave us a comment below and tell us what you think of this video, and then what other kinds of projects you'd like to see in the future. And then make sure to subscribe to our channel so that you don't miss any additional content in the future that we're going to have coming out for you.